Hello and welcome. So let's start our journey into the world of cybersecurity by looking at the top 10 cyber attacks of 21st century. And some of these are really interesting ones. So the very first one was the Melissa virus. Now what happened in the Melissa virus was that it happened almost 2 decades back, right? So in late March 1999, there was a programmer named David Lee Smith. He actually hijacked an American online account. So like we have Gmail accounts, Hotmail accounts. At that time, it used to be AOL accounts. So he hacked one of the AOL accounts and used that account to post a file on the internet news group, which is called alt.sex. And it promised that it will give you dozens of passwords to some fee-based adult websites. So normally the adult websites are fee-based. So what this guy said that if you click on this link, I will give you loads of passwords to these adult websites. And when people saw that, they've downloaded that document, opened it, and it caused havoc. It spread like wildfire across the internet. And so it was really a big cyber attack at that time. And if we go back, then we'll talk about the NASA cyber attack. So NASA, if people don't know, stands for National Aeronautics and Space Administration. It is actually a US government website, or a US government agency, I should say, which is responsible for science and technology related to air and space. And just have a look, guys. A 15-year-old computer hacker caused 21-day shutdown of NASA computers. It's a US government agency. And still a 15-year-old child was able to hack into the NASA computers, right? And this boy was actually called Comrade. He is quite popular with the name Comrade and just got around 6 months in jail. Let's take a look at the next one. Another interesting one is attack on Estonia. It's a cyber attack in 2007. So it was back in April and May 2007 where the hackers actually unleashed a wave of cyber attacks which crippled dozens of government and corporate sites in Estonia. And you know, Estonia was considered to be, or is considered to be, one of Europe's most wired country. And that is what the attack was. So it was, normally they say that it was Russians who attacked Estonia. And the method that they used was denial of service attack. Now, this might sound as a new term to you, but don't worry. All these types of attacks, phishing attacks, malware attacks, denial of service attacks, we would be understanding these in the upcoming videos. We'll do deep dives into this. You guys will get a very good understanding of how all these attacks work. But for the moment, I just want to tell you that whatever we'll be learning is what these attacks are related to, right? So the next one is Sony PSN. So I believe if you are into gaming and all, then you must be aware of Sony PlayStation. So there's a Sony PlayStation network. And in this, the PlayStation network, hackers had access to data of 77 million users. And just to have a look at it. So Sony actually warned that the names, addresses, and other personal data of 77 million people were hacked or stolen. And this is what we call the PII, which is a personally identifiable information. It is things like your name, your email ID, right? Your, date of birth. This is your PII. And the hackers in this case were able to steal data related to all this PII. Okay. Then we move on to another popular company, Adobe. I believe a lot of people are aware of Adobe Photoshop and lots of products that Adobe does. So even Adobe confirmed that they had a cyber attack which compromised customer accounts as well. So the software maker said that it is now believed that the usernames and encrypted passwords had been stolen from 38 million of its active users, right? And so if you see, Adobe also announced that the hackers stole parts of the source code to Photoshop, its popular picture editing program, right? And they told everybody to just change their passwords, right? So guys, here we are talking about big names. So these are not small companies. They are big names, and still these companies can be hacked. So just think about your organizations. Another interesting attack coming up is RockU. And guys, I have a demo coming up later where we will make use of this RockU file as well. I'll actually show you. So what was this RockU? It was the largest password compilation which was leaked online. And this was almost 100 GB text file with 8.4 billion entries of passwords. And you know what kind of passwords were there? Because I always say people are lazy when they keep passwords. They keep passwords like password 123 or PA55WORD or security or summer, winter or summer 123. So this is that collection of all those passwords. So they actually created a file, and even they hacked a lot of people's accounts, and all the passwords that they found, they stored in this file, which is called the RockU 2021 compilation. And in our upcoming videos, where I will show you the dictionary attacks, I'll show you how the hackers make use of these say compilations or these words to actually hack into people's accounts. So remember, RockU 2021. Oh, another interesting one, very interesting one. When I was reading about this, it's really surprising the way it was done. So it actually happened back in year 2016. Now, all of us are aware of the Russia-Ukraine war, but guys, it's been going on even before this. So if you see what happened, it was back in December. Just think about it. It was a cold winter night. And you know what the hackers did? If you really read about it, you'll be surprised that the guy who was on duty, he saw that a cursor like this started navigating towards the buttons which were controlling the circuit breakers. And he was not able to do anything, and the screen just went on and confirmed the action, and lots of regions, they lost lights, electricity and heating. So just imagine the helplessness of that guy who was on duty at that time. The hackers actually hacked into his computer and took control of it and took control of all the circuit breakers, and there was no electricity. Just think about the people who were in the winter cold night. So these are the kind of hackers you have. Then we talk about the WannaCry ransomware, very different type of ransomware. So what exactly is a WannaCry attack? So the WannaCry ransomware, normally they call it, it's a global epidemic, right? You must have heard about the term pandemic. So before that, there is epidemic, because where loads of millions of people are impacted, right? And happened back in 2017. So what this ransomware did, it actually attacked computers, mainly the Windows operating system, and the users' files were taken hostage. Normally, you know, with hostage, what what people do is they will take a person hostage and they will ask for money. In this case, what the hackers did, they took your important files as hostage and then asked for money, but that money was in the form of bitcoins. So they were charging bitcoins. If you give us bitcoins, the hacker said, only then we will return your important files, your secure files, right? So this is how the WannaCry took place. And my goodness, one of the biggest cyber attacks of 21st century, Marriott Hotels, guys. Another big name. So just think about it. When you go to a hotel, right, you are asked these kind of things on the desk, or when you go to the hotel, or when you go to booking.com or any website, or a hotel expects you to give your name, email address, your phone number. What more can be bigger than your passport numbers? Guys, in this case, the hackers published all this information online. It was a clear breach where the personally identifiable information was leaked by the hackers. And again, a big name, Marriott Hotels. So yeah, so with this we come to the end of top 10 cyber attacks of 21st century. So all I need to tell you that whatever the hackers used in this, they were not using something really different or something that we won't be studying in this lectures or upcoming lectures. they either use some form of a malware or a phishing attack or a denial of service attack or a dictionary attack, right? These are like common kind of attacks. It's not they were using very sophisticated cyber warfare weapons, not at all. So that's why I always say it's very, very important to know your basics. If you want to have a career in the world of cybersecurity, you really need to have very good understanding of these foundations. And that is what my aim is to teach you guys. Thanks for watching. Hello and welcome. So after taking a look into the top 10 cyber attacks of 21st century, it's actually time to take a look at live cyber threats. So guys, you will actually be surprised that these are the attacks that are happening every time. So there is this website, if you go to threatmap.checkpoint.com, you can actually see a map, which we say a live cyber threat map. And if you see here, it actually tells you all the various types of attacks that are taking place currently, right? And I can actually reduce this frequency just to be sure that what exactly is happening. So if you see here, it's just pointing that, okay, probably somebody from United States is trying to attack Mexico. Someone from US is trying to attack Italy. Somebody within UK is trying to attack someone from Denmark to Germany, within Israel, from US, somebody trying to attack Brazil. So this is happening all the time. That's why, guys, this topic of cybersecurity, understanding the basics of cybersecurity, the foundations of cybersecurity is so important for us. And here it actually tells you that what kind of attack is it. So if you see there is some web client related, there's some infecting the URLs, and these are the types of attacks, mainly a malware, phishing, exploit. So if these are new terms for you, don't worry about it, because in the upcoming lessons, we will actually tell you what is a malware. We will actually tell you what is phishing. Not only that, I will actually do some demos for you to show you how easy it is for hackers to create phishing websites. So we'll go through all that. And if you actually look at on the right hand side, it shows the top targeted countries. So at the moment, like when we are recording this, it's Mongolia, Nepal, Georgia, Macau, Kenya. So these are most vulnerable countries today. So these are the countries where a lot of people are trying to attack these countries. And the top targeted industries, it even gives you that. So it is communications industries, right? If you are in telecom industry, education industry, government, even government is being attacked. So, and this is like one of the key attacks, like, because this cyber warfare is happening all the time. So probably Russia is trying to attack the Ukrainian government as well. So we know the countries are at war, but the cyber warfare is also going on between governments as well, right? And it also tells you what are the different types of malware types that we have with the highest global impact, it's something related to the mobile ones, some backdoor malware types, or botnets. So where the hacker would have used some botnets to use kind of denial of service attacks. Again, we will study about DDoS attacks, distributed denial of service attacks. So all I wanted to show you was that at one stage we studied the top 10 cyber hacks or attacks of 21st century, but it hasn't stopped. These are happening all the time. That's why it's very important that be vigilant. So thanks for watching. Hi folks, welcome back. It's time to take a look at the demand for cybersecurity professionals, or the cybersecurity market size. And if you are thinking to take cybersecurity as a profession, what is the future, or what's the scope of cybersecurity, right? So there's a company which is Polaris Market Research. They normally publish such data. So Polaris Market Research is a worldwide market research and consulting organization. And they actually work on the market size estimation and also forecasting. And this is what they did for cybersecurity. So if you see, they said the cybersecurity market size, and they start from 2018 to going up to 2030. Right, and we're talking about a market size in US billion dollars. Okay, when it says USD billion, it means it is US billion dollars, right? And if you look at it, it really can show you an upward graph, right? The graph goes like this. So from 2018 up to 2030, the graph is here, right? And here in 2021, they published that they were looking at a market size of 217 billion US dollars. And just look at it when it would be in the year 2030. And on top of it, they also mentioned that this the cybersecurity market size has a CAGR of 9.7%. So CAGR stands for the compound annual growth rate. So here we are talking about an annual growth rate of 9.7%, guys. And just try and look at how the data is published. So if you look at the colors that they use different colors for different continents. So for North America, Europe, Asia Pacific, Latin America, Middle East, and Africa. So if we pick 2030, you can see that everywhere, almost every continent would be growing. If you look at, say, North America today here, and where would it be in 2030 here, right? If you talk about Europe is looking very small in 2018, but look at in 2030, right? So this is the kind of comparison they give, that this is the kind of forecast they are giving, and I believe it really looks really positive. So I would say you are at the right place, learning the right thing for the future. Thanks for watching. Hello and welcome. It's time to take a look at what is cybersecurity and why we are here, because we'd be studying the fundamentals of cybersecurity. So I really want you to have some good understanding about what really is cybersecurity. So as I always say, always try to break the word or always look at the root word itself. So cybersecurity. What does cyber stand for? What is the English meaning of cyber, right? If you pick up the Oxford Dictionary, cyber, it says anything that relates to computers, information technology, and even virtual reality. So this is what the term cyber means. And security, obviously, we all know that security stands for, as a root word, secure, like you're keeping it safe, right? So cyber security refers to the practice of protecting computer systems, networks, data, digital information from various threats and attacks. So it's basically, we are talking about that it's a practice, right? You need to protect your computer systems, your networks, data, even talking about things like IoT or Internet of Things. And there are several artifacts in cybersecurity. So there are loads of artifacts, but we'll talk about some of this, which are really important. So we start with protection against threats. So cybersecurity is the field which is dedicated to defending digital systems and assets against a wide range of threats. Now, these threats can be in the form of viruses, malwares, phishing attacks, hacking, cyber criminals, and other malicious actors. And don't worry if you don't know these terms. In forthcoming videos, we will do a deep dive into what is a malware. We will even do a video on phishing. I will actually show you how the hackers create these phishing attacks, how you need to protect against these phishing attacks, right? Then we talk about the information security. So information security measures to ensure the confidentiality, integrity, and availability of sensitive information. So the CIA triad that we learnt about, the CIA triad which says confidentiality, integrity, and availability. So then we move on to the prevention and mitigation. So in the world of cybersecurity, we say that certain things can be prevented, but there are certain things which you can't prevent. You can't lock down every user. If you're allowing a user, then you need to look at the ways to mitigate. The way is that how you can mitigate the risk. That's where the prevention and mitigation comes. So cybersecurity aims to prevent the attacks from occurring and to mitigate their impact. So basically, mitigate means to reduce their impact if they do occur by reducing the potential damage and the loss. Then we talk about the security measures. What kind of security measures can you take? So it involves the implementation of security measures such as firewalls, intrusion detection systems, intrusion prevention systems, which are called the IPS. We talk about antivirus, software, encryption, And say even you can talk about all these various access controls. So all these come under the security measures. What kind of security measures would you be taking to secure your environment? Yes, and another set of professionals that are coming up are called ethical hackers. So, and we will study it when we look into the various type of hackers, like white hat hackers and blue hat hackers. So same way there are ethical hackers. They are white hat hackers, which these are the guys who simulate attacks to identify the vulnerabilities in the systems, networks, and applications. And by doing so, they are actually helping the organizations to strengthen their security portfolio. And then moving from security measures, we move to security awareness. So it's not only that you take measures, you need to educate your users. Very important that as cybersecurity professionals, you need to create that awareness. So you need to educate the users about the safe online practices to reduce the likelihood of falling victim to social engineering attacks or cyber threats. Probably something what I'm doing right now, creating a course on cybersecurity foundations. We'll be teaching you how these phishing attacks are done, how you can prevent such attacks. What is encryption? How can you encrypt the data? What are digital certificates? So don't go anywhere. Just stick to the course until the end. I believe you would have very good understanding of how cybersecurity foundations work. Then we talk about incident response. So as I said, certain things can be prevented, but certain things have to be allowed. But what about if an incident takes place? Right? What if a security incident takes place? How are you going to respond to it? How are you going to resolve it? So that all comes under incident response. Then we talk about the regulatory compliance. So cybersecurity involves adhering to the industry regulations. So there are loads of regulators if you look at. So there is CIS benchmarking, there's GDPR in EU, and every country, every continent, they have their own regulatory regulators that you need to comply against. So it helps you to protect the user data and ensure privacy. And not only this, it's a continuous effort. You need to continuously work on this. You need to continuously and consistently monitor the systems and networks for suspicious activities, unauthorized access, and you need to respond to potential threats. And now with the advent of cloud, this cloud security has also come into picture. So previously, when we were just on internet, we used to be client server architecture. You were on a web browser and you were, say, accessing HSBC, Myntra.com or web servers, right? So we always used to talk about internet security. But now cloud has become a part of our life. So that's why cloud security becomes a very important artifact for cybersecurity. So as part of cloud security, it says to ensure the security of data and applications hosted in the cloud environments, which may involve specific challenges and considerations. So because what is happening, people are moving or organizations are moving their workloads from on-prem or on-prem data centers onto the cloud. So you can think about it that the entire workloads of a bank, of a financial company is actually sitting there in the cloud. They're running from the cloud. That's why cloud security becomes really important. So when we say cloud security, the biggest artifacts of cloud security, I would say, would be identity access management. It would be how you would ensure data at rest encryption, how you ensure data in transit encryption. There's a difference between these. We'll study all this. So don't worry about it. For the moment, it was just to give you a good understanding of what is cybersecurity. So all these artifacts taken together comprise of cybersecurity. Just to summarize, it refers to the practice of protecting your computer systems, your networks, your data, and the digital information from various threats and attacks. Thanks for watching. Okay, so after taking a look into what is cybersecurity, it's time to take a look into another important topic in cybersecurity, which is the backbone of cybersecurity, or you can say it's the foundation for cybersecurity. And we call it the CIA triad. Now, what does CIA stand for? So CIA stands for confidentiality, integrity, and availability, right? And there is this word triad. So if you actually search for this word, the triad, the meaning of triad is a group of three related things. And that is how we form a CIA triad. So let's take a look. So the very first one is confidentiality, right? So again, we look at the root word for confidentiality. The root word for confidentiality is confidential. When we say something is confidential, it means that something that needs to be kept secret, right? So confidentiality focuses on the prevention of unauthorized access to sensitive information. So what it means is that only the authorized people, only the privileged admins should have access to that data. So any unauthorized person who is not authorized to have access shouldn't be allowed to have access to that kind of sensitive information, right? And it ensures that only authorized individuals can access and view the sensitive data. So first of all, you need to ensure that only authorized people can view the data. And you also need to prevent that unauthorized people can't see the data. So both the things, allowing authorized people to see and disallowing the unauthorized people not to access, right? And it says a breach of confidentiality can lead to data leaks, obviously, right? If your data gets in the hands of unauthorized people, then it can lead to data leaks. They can hack your servers, they can hack your databases, they can publish it online. So, and it leads to privacy violations and even loss of trust. So your company can lose trust in the market, and it also causes reputational loss as well. The next one is integrity. Now, what is the meaning of integrity? If I say integrity is state of being whole and undivided. So in cybersecurity, what we mean by integrity is that if you are sending a message from a sender to receiver, then the message should go as is. So it shouldn't be tampered or it shouldn't be modified by anybody, right? And this is the whole foundation of cybersecurity, network security, packet switching. We will learn all about all this in forthcoming lessons. But that is what integrity talks about, that the message you are sending should be accurate, should be consistent, right? It shouldn't be changed by anyone. It shouldn't be modified. So let's quickly take a look. So integrity is concerned with maintaining the accuracy, consistency, and trustworthiness of data, right? What it means is that the sender, if sender is sending a hello message, then the receiver should be getting a hello message. It's not that somebody comes in the middle or a hacker comes in the middle, changes the data, and the receiver even doesn't come to know that, oh, the data has been changed, right? So that is what we say, maintaining the integrity. And it involves preventing unauthorized modification, deletion, alteration of data. Although they are one and the same thing, but all it says is that the message shouldn't be modified, the message shouldn't be deleted, or the message shouldn't be altered, right? Or changed. Now, it says how you can do that or how you can achieve it is you can use various techniques like data validation, like you can validate what the message that was sent by sender is the same one. You can use hashing. So don't worry about it if you don't know about it, because we'll be dealing with hashing, digital signatures at length. At length, we will be looking into these topics. I will be doing loads and loads of demos for you guys to give you a very good understanding of what is hashing, what is digital signature. So for now, just try to understand that how you maintain integrity is through the through various means or techniques, and one is hashing and other is digital signatures. And what if the integrity is breached, right? What if somebody has changed the data? So obviously it can lead to data corruption. So just think about where you are keeping all your data in your databases. So if somebody is changing the data and it's not coming through proper means, then it can even corrupt the data. This can lead to misinformation. Misinformation in the form of, let's say you're doing some regulatory reporting. You'll see that you are reporting against the wrong data because somebody has changed the data. And obviously it can lead to loss of data reliability because you can't rely on that data because somebody has already changed the data. The next one is availability. And guys, a lot of people are actually surprised when they see availability being a part of security. But yes, that is the truth. Availability is one of the keys of CIA triad. What does availability stand for? So availability, again, the root word is available. So if you are supporting a service, then that service should be available to your clients. That's why it says refers to ensuring that authorized users have timely access to data and resources. So what it means is that when the user wants to use your service, it should be available at that time. It shouldn't be the case that because of outage or because of some other reasons, your service itself is not available. Then you are going against the CIA triad, right? And it focuses on preventing disruptions or outages that could lead to unavailability of services. So the focus is that how you can prevent disruptions. So it is more of not only availability, sometimes we call it high availability. How can you make your service highly available? Meaning if one component fails, the other component takes over, and also involves a redundancy, which you can see next as well. So you are focusing on preventing disruptions to your service, right? Because you want to make your service highly available, or you want to prevent any outages that occur on your service. And as I said, it involves redundancy. Redundancy is that, let's say you need to have redundancy at disk level, you need to have redundancy at network level. So if one component fails, the other component should be able to take over the work or the workload, right? So it involves redundancy, failover systems, disaster recovery. So disaster recovery means that, let's say you have got a data center in UK, or if you have two data centers in UK, so they should be apart, several miles apart from each other. So if you have a problem on one data center, the other data center can take over the workload. Sometimes there is disaster recovery done at regional levels as well, or country level as well. So certain companies do that. So if they have a data center in UK, they would say, what if something goes on in UK, or there is a war or something, right? So they need to have a data center, let's say in Germany, right? So this is how we take care of the disaster recovery. And what happens if there is availability breach? What happens if your service is not available? Obviously, it will lead to interruptions. People or your clients won't be able to use your service. It will lead to downtime or outages and loss of productivity. Your company would be losing money on that because your service is not available. Clients can't use it. Just think about Amazon.co.uk or Amazon.com, where you do online shopping, Myntra.com. If that service itself is not available, how would the company make money, right? It will lead to interruptions, downtime, and definitely loss of productivity. So with this, we come to the end of the CIA triad. So I will always say that please keep this on the back of your mind whenever you're designing a service and you want your service to be secure, or you want to be secure as per the CIA triad. Always remember that you have to take care of confidentiality, integrity, and availability. Thanks for watching. Hello and welcome. It's time to take a look at various kind of attacks that you should be aware of as a cybersecurity professional. So the very first type of attack that we will discuss is a malware attack. So what exactly is a malware? So a malware, or you can say a malware attack can basically compromise a computer system or network by infecting it with malicious software. So you can think of a malware as a type of a software which can actually affect your computer system or the network. So very important, right? So you're compromising, or the attacker is compromising a computer system or the network by infecting it with malicious software. It is kind of you can say a rogue software or a malware that they use. So then we understand what is a malware. So malware is basically any software that is designed to cause harm or damage. So you can think of it as a kind of a software, so let's say a database itself is a software, or an Outlook Express is kind of a software, right? But this is a type of software which has been designed. The only purpose for this software is to cause damage, to cause harm. So very important, it's type of a software that can cause either harm or damage to a computer system or a network. So that is what the aim of a malware is. Now, a malware can take various forms. It can be in the form of a virus. You would have definitely heard the term computer viruses. Then we also call it worms. We call it Trojans, ransomware, spyware. Right? These are all different types of softwares or malwares you can talk about. So whenever you are talking about any viruses, worms, Trojans, then you are talking about a malware. So how can they come, right? How can they approach your system? So they can easily enter through email attachments. Let's say a hacker sends you an email with this attached malware. So if you click on that attachment, or you, let's say, download that attachment, then it can start spreading across, right? It can even start spreading across your network. It can start affecting various devices, right? Or you can go to infected websites. So there are a lot of websites that hackers have created, and they will lure you to that. They'll say, okay, you want to earn, say you want to say invest £100 and you get 100,000 pounds. These kind of websites they create to lure you into that. Or they will lure you into some live Premier League match, or live cricket match, or live Wimbledon match. They say, just click on this link and I'll take you to the live Wimbledon match, right? So this is where your system can get affected with malwares. Or they can be some malicious software downloads. Let's say you go to certain sites where you can download certain softwares. You are looking for some AI-based softwares, and the hacker will say, oh, you take this software and it can automatically create presentations for you. So you try and use that link, and you eventually understand that, oh, you've actually been infected by a malicious software. And what's the purpose? Right? What's the purpose of a malware? The purpose of malware attack is data theft. They want to get the data out of your system. They want to either damage your system, or they want to disrupt the normal system operations. So that's what the aim of the attacker is. And we looked at various types of hackers as well. It can be different uses you can put this to. Now, the problem is that it's difficult to detect and mitigate, as the malware is designed to evade certain types of antivirus as well. So the hacker, they are so intelligent that they can design the malware in such a way that even an antivirus won't detect it as a malware, because antivirus would be scanning your systems, and they can design it in such a way that the antivirus wouldn't think that it is a virus. It would just think that, oh, probably it's just a piece of software. So that's why it's very difficult to detect. Now, the main thing is how you can prevent a malware attack. You can prevent a malware attack through regular software updates, or we can say security updates. Very important. If you are having software database, always keep performing your security updates, your OS updates, right? Keep updating your security patches. Always use strong passwords. Never use weak passwords. Always use strong passwords, long passwords with characters, numbers, special characters, and always ensure that your staff is undertaking some security awareness training, because very important, they are not clicking or they're downloading some stuff. And they say that what's the way to remediate? Okay, now let's say you are affected, or your system has been affected. What is the way to remediate it? The best way to remediate is to isolate. Very important. If you don't isolate, that it can start spreading across your network, right? And can affect a lot of more machines. So very important that you isolate the system that has been affected by malware from rest of the network, right? So with this, we come to the end of what is a malware attack. In the next video, we will take a look at what is a phishing attack. Thanks for watching. So after having a good look at what a malware is, it's time to take a look at what is phishing, right? So to understand phishing, I would say it's best to go through this workflow. Let's go through this workflow. So what does it say? So it starts with the very first point, which says attacker sends an email to the victim, right? So you are the victim or a person. He or she, the victim, clicks on the email and goes to the phishing website. So the purpose is that what they do is they will actually build a web page very similar to the original one. Let's say you are going to Amazon. Let's say you have to shop around on amazon.co.uk, right? So what the hacker will do is they will create a website which looks absolutely similar to Amazon. So you will have the logo of Amazon, you will have the login page, everything it looks similar to Amazon. There would be only a very specific area where they would make some changes, but as such, if you keep on left side amazon.co.uk and on other side you keep hacker's website, you won't be able to figure out any difference. That is how close they can design the website, right? So what happens, you feel as if you are on amazon.co.uk. You don't know that because you've just clicked on a link, you go to that website, you feel it is amazon.co.uk, and what do we normally do? Yes, we normally go and log in. And that is what the hacker wants from you, that as soon as you log in, you would be entering your username password. So when you enter your username password, normally on your Amazon website or your hsbc.co.uk, you would be taken to the actual web page, or you would be authenticated to that web page. But in this case, nothing happens. All what happens is this phishing website captures your credentials and send it back to the hacker, right? So you understand, you click on a link, that link opens a website which looks very similar to amazon.co.uk. You think that you are on the shopping website, you put your username, password, that does nothing but actually sends the credentials back to the hacker. And the hacker then uses these credentials to access the actual website. So now the hacker has got your username password of Amazon. And what will happen? Yes, the hacker can just simply go to amazon.co.uk, use your username password and start shopping around, right? So that is what we call a phishing attack. Let's take a look in detail. So in a phishing attack, what we are doing is you are tricking a user into revealing the sensitive information such as the login credentials, your financial data or personal information. That's what we looked at, right? You're tricking a user. You are telling the user, hey, just click on this link and I will take you to amazon.co.uk. But it's not actual website. The use of fraudulent emails, text messages or websites that are designed to look legitimate communication. As I said, that looks very legitimate. It looks as quite similar to your actual website. And how they do is they will either send you an email which will say, okay, this is something, or you can say Amazon is running a sale of 80% off, something like that they will do. This is kind of fraudulent email, or they will try and send you a text message, or there are certain websites which are designed that way. So the aim is you just click on that link and go to the fraudulent website. The goal is to trick the user into clicking on a link. As I said, you click on a link to provide the personal information. That is what you did, right? So you clicked on that link and you were taken to a specific website where you give your credentials. You create a sense of urgency or emotional appeals. That is how the hacker will do. They will either send you something saying, maybe they will send you from the tax authorities. The email would look very legitimate. You will feel that as if HMRC or the Indian tax government has actually sent you an email saying, hey, you've done a fraud and we've caught you. So you need to click on this and you need to get the details of what fraud you have done, right? Or they will do some kind of emotional appeals. They will say, oh, there is an earthquake somewhere. We really want you to have a look at this and probably give us some money and all that stuff. So this is the way they will do. And often appear to be legitimate communication from a trusted source such as a bank or an employer. As I said, it looks very legitimate. It looks as if the bank or HMRC or the tax authorities are sending you, but behind the scenes they are using a fraudulent website. Okay, what are the ways to prevent it? Very important. I would say the best way to prevent is your users should be educated. Being cautious when clicking on links. You should be really cautious. So if you're getting an email from HMRC, if you're getting an email from tax authorities, normally they don't send emails. They would always send you letters by post, right? But even if it is by email, you should always be very careful. Look at from where exactly is it coming, from which domain is that email coming. Is it coming from a specific right domain from Indian tax authorities, from HMRC gov.uk? So you have to be very careful that who is the sender of that email, because sometimes from that you can get an idea. Look at the text, how they are describing it, right? So these are the ways that you can be really cautious before you start clicking anything, and never download any attachments, right? Until unless it's coming from an authentic source, please do not download any attachments from these emails. And what's the way to remediate it? Now, let's say if you have been attacked, so the best way to remediate this is that you should report this incident to the appropriate authorities and take the steps to secure any compromised accounts or system. And also, as we looked at in the malware attack, you should try and isolate that system from your network so that it doesn't spread across, right? And once it has happened, you should straight away go ahead and start changing your passwords. If you're using your password elsewhere as well, then it's always recommended that please change your passwords everywhere if you feel that you've been a victim of a phishing attack, right? So this was a video on phishing attack. So keep watching. There are more interesting attacks we'll be talking about. Thanks for watching. Okay, so welcome to the world of Kali Linux. So guys, I'd like to say that whatever you're going to see, it's only for educational purposes. Please don't use this to harm anybody. Why we are doing it? Because I would like that you should have good understanding of how phishing works or how easy it is these days to create phishing websites, right? So there is a software called Kali Linux. Normally, as part of ethical hacking, we use Kali Linux, which can be actually downloaded from the internet. You can use it as part of the UKM software. There's a UKM software. You get a virtual machine for Kali Linux and you can just use that. So here I'd like to show you a phishing attack and how easy it is to create a phishing attack, right? So once you're in Kali Linux, you just need to go to your terminal. You need to log in as root. Okay, then there is something called set toolkit, right? You give this, and in that it will give you what kind of attack do you want to create, right? It will ask you, you want a social engineering attack, a pen testing attack, or penetration testing, third-party modules and all. So what we are interested in is a social engineering attack, right? Here again, you get various kind of options. You get spear phishing, website attack vectors, infectious media, loads of things are there, right? So we are just interested in, let's say, the website attack vectors. In website attack, we are actually interested in number 3, which is a credential harvester. So here I told you that what we are trying to do is we are trying to create or clone a website, and the purpose is that if you see that website, you will feel as if it's the actual Google or Gmail website. And the attacker wants you to key in your username password, and the attacker will be grabbing your inputs, like whatever username you gave, whatever password you gave. So in this case, let's pick web templates, right? In web templates, it asks what is the IP address, where do you want to grab it? So where are you, where do you want the output to be sent back? So in this case, my machine is a Kali Linux machine and the IP is 192.168.64.2. I'll just say enter. It says, okay, that's fine, but which template you want me to use? You could use Twitter, you could use Google. I say, okay, I want just Google to be used. Okay, so here what it does is it's actually cloning the website. It clones it for you. And it says the best way to use this is if the username password from the fields are available. Okay, so that is what it wants. So let's say this is your attacker. He's waiting on the input, on the output from your side. He creates this website and sends it over to you. You feel you click on that link, or let's say you've got it in an email, you click on that link and you go to that website. Let's say you are a client here. In this case, the client and server are same, but let's say you are the client and you say localhost, right? So if you see, if I don't actually look at the URL, if you see, it actually looks like the real Gmail or the real Google account. Nobody can say it's a fake Google account. And now see the magic. So let's say I give something like cloud. I give my username as cloudalchemy@gmail.com. Okay. And in password, I give something like I have been hacked. Okay, so I'm giving this, I'm doing a sign in. Now, what did I tell you? The purpose is that the hacker wants to grab these details, the username and the password. And what will happen is when you click sign in, okay, it is actually opening the real Google page. And you realize, oh, maybe I didn't sign in. So again, you press sign in. But what has happened at the back end is, let's take a look quickly what has happened at the back end. So if you see, the hacker has actually grabbed your username and password. So if you see, the hacker was waiting on you. Let's say you were the client, you keyed in all these details. Now this information would have flowed into the hacker, and the hacker would have got your username, which I gave cloudalchemy@gmail.com. And just take a look, guys, just take a look how easy it is. The hacker has now even got my password, which is I have been hacked. So that's the beauty, right? So now the hacker has got my email ID, it's got my password. What the hacker can do, just simply log into the Gmail, to my Google, and just make use of it, right? And that's where it says you should be really careful when you are clicking, when you're visiting websites. Don't click on links that you're not sure of. Or when you're keying in your details, you should always look at a URL. Does it sound a bit fishy? Or is it a normal URL? Very important. And on top of it, it's always said that always have MFA in place, like a multi-factor authentication. So let's say if I had a MFA in place, even if the hacker got my email ID, password, still the hacker won't be able to get in because I've placed an MFA, a multi-factor authentication, like say some kind of OTP that comes to my phone, or it could be through authenticator softwares that Google does or Microsoft does. So there are ways to protect yourself. So again, I would say this is more of an educational video to teach you guys how easy it is to create a phishing website. So it's just that we as cybersecurity professionals need to be very sure that we need to protect our clients and how we can catch these phishing websites. So I hope you liked the video. Thanks for watching. Okay, so the most, I would say, common and the oldest type of attack that a hacker does is a password attack. So what happens in a password attack is that the hacker tries to guess your password. And that's why we always say that, guys, keep your password that is not easily guessable. Or don't keep common words like summer, winter, password 123. Most of the people are really lazy, right? And that's why they keep very simple passwords. And remember that the hackers are really intelligent. They are smart guys and they know people's mentality, that people are lazy. And that's what they try to use. So let's take a look. What is a password attack? So in a password attack, there is an attempt to either guess or crack a user's password, right? So here what the hacker or the attacker is doing is trying to guess your password. Now, as I said, people are lazy. They would either keep passwords like password 123 or London 007. So very common words they will try to use. And the hacker will try to guess based on that. So there are the password attack can take different forms, and we'll take a look into each of those. So one could be the brute force attacks. Second type of attacks are the dictionary attacks, and third type are the social engineering attacks. Right now, what is a brute force attack? And we have a very interesting demo coming up just after this lecture, where I'll actually show you how easy it is for hackers to create a brute force attack. So what we do in brute force attack is the hacker will have an automated software to systematically try every possible combination of characters. Now, the thing is that in brute force, there can be two ways. Either you can manually try and go and try each password. But what a hacker does in brute force attack is they create a script. You could think of a shell script, right? And they are actually having and trying to attack the user by trying different combinations, just different permutations, different combinations of various characters. That is called a brute force attack. Then another common one is a dictionary attack, and this is what we will actually show you in the demo. What we do in dictionary attack is a hacker will have kind of, it's not like an Oxford dictionary. It's a dictionary of words. It's a dictionary of passwords. So what the hacker will do, they'll keep all the common passwords that people keep, like password 123, London 007, summer 123, winter 007, some very, very common ones. So they will actually maintain a good list of all these, say, words and phrases even, right? And what the hacker does, they try to then use each and every, say, word from that dictionary or from that file and try to, say, attack or try to guess that whether it is this password or not, right? This is called a dictionary attack. The third type of attack is a social engineering attack. As the name suggests, social engineering, the hacker is actually tricking the user into revealing their password through tactics such as phishing, pretexting, or baiting. Something what we just saw in previous video, where it is a kind of a password attack, right? But the way a hacker is trying to get a password from you is he or she has created a phishing website. You log into that phishing website. You are unaware, you think it is a Google, you think it's a facebook.com, you key in your credentials like username, password, and the hacker actually gets all the details. So keystroke logging, whatever you are typing, the hacker is actually getting the details. Right? So the thing is, how can a hacker be successful in this? The only way for the hacker to be successful is if you really keep weak or easily guessable passwords. So very important, never keep weak passwords. That's why the general recommendation is always keep around 12 characters, have numbers, characters, always have special characters, because if you're keeping long password, then it becomes difficult for the hacker to break it as well. And the password shouldn't be easily guessable. Whatever is going on in the world, don't keep passwords as per that, right? So what's the way to prevent it, right? The best way to prevent, as I said, always keep strong and unique passwords, enabling multi-factor authentication. I think we spoke about multi-factor authentication in previous video as well when we did phishing. So always important, have two layers of password. So the first layer is your password. The second layer of security is your MFA. We call it MFA, or the multi-factor authentication. Very important, right? As I said, you can have MFA in the form of an OTP or one-time password coming onto your phone, or you can use some authenticators. There are authenticators available from Microsoft. There are authenticators available from Google. So the first layer is you give your password. The second layer is you go through the MFA, right? And what's the remediation? So the best remediation, they say, is if you have been attacked or you feel that your password has been compromised, always go ahead and change your password, and not at one place. Let's say if you are using as password 123 and you are using this in Facebook, you are using it on Google, you are using it on Twitter. So if you change at one place, please change it at every other place. Try to keep a complex password, something like I would say a minimum of 12 characters, with numbers, characters, and alphanumeric along with special characters. That's quite important. So the remediation is please change your password immediately, and on every website where you've kept that kind of password, right? So with this, we come to the end of the video for password attack. In the next video, I'll actually show you the demo. You will be surprised to see how easy it is for a hacker to guess your password. So don't go anywhere. Keep watching. Thanks for watching. Okay, so after getting some good understanding of what are password attacks, it's time to take a look at a demo of password attacks. And guys, you'll be really surprised how easy it is for a hacker to guess your password. And we actually in the previous video talked about dictionary attacks. Now, what exactly are these? So again, we are back in Kali Linux, and in Kali Linux, there is a specific directory, which is USR, or user share word lists. As the name suggests, word lists, right? So when you go into the directory, you'll see there are two types of files. One is a zipped file, which is rocku.txt.gz. It's a pretty humongous file, right? So what I've done is I've actually done a unzip or gunzip on this, and I've kept it in the temp directory. So if I show you this one, rocku star, so this is actually inside the temp directory. If I go in temp Okay, so if it is not there, we can go back and gunzip it, right? Okay, just wait. Yeah. So what I'll do is I will cp this to temp, right? And then I am in temp, and then I can do g unzip rock-u this. Okay, so if I try and look at the contents, you will be really surprised to see the contents of this file. Okay, so just have a look at the content. So what it is basically a cluster of, you can say, easily guessable passwords, right? People are lazy, I told you. 1 2 3 4 5 password, baby girl, Nicole, I love you, like very simple words that people would normally keep, and it's a humongous list, right? And also the important thing is it's actually also based on the passwords that have been hacked. So normally when the hackers are hacking the users, they sometimes publish these passwords as well, right? So and it keeps on getting added to their dictionaries. This is a kind of a dictionary we are maintaining, right? Same way there is this file which is much less, but still there are a lot of easily guessable passwords. It's called a fast, if you see, yeah. Okay, so this file is called a fasttrack.txt. So now what we will do is we will, as part of this demo, we will create a user, and once we have created a user, we will give that user a password, and we'll give that user a very simple password, right? And then we will see how a hacker will try and attack and guess the password. Very interesting. Let's take a look. So there is a command, user add, let's say I say testing. Okay, so I'm just creating a user called testing in Linux, and I'm giving a password for that user, say a very simple password like password 123. Okay, password 123. Okay, perfect. All good. You're with me now. So I have just created a user called testing, and I've just given a very simple password, which is kind of easily guessable, but nobody knows. Like, it is Linux. It's not that you can just go in Linux and find the password. There's no way to do that, right? So what we will do within within Kali Linux, there is actually an inbuilt utility. We'll talk about that, which is called a Hydra. There is a utility called Hydra. And what I'll do is I'll just simply change the user to testing, right? What I'm saying is, Hydra, can you try and start attacking or start guessing the password for testing? And as a source, you need to use the words that are in fasttrack.txt. And how do you want to use, or which protocol or which service you want to attack or go to? You have to do an SSH, right? So you just have to try an SSH on that user. And what is the what's the IP we are attacking? It's the same IP. Basically, you could attack any specific IP as well. In this case, we are saying the same IP, and it's just, we are saying it should run in a verbose mode, and it should also give us actually, whenever it finds a password, then it should actually stop at that moment. Okay, so let's take a look. Okay, so time to see the magic. Okay, so now you can see that the hacker is automatically trying to target the machine using the testing username, and he's trying different combinations of password. If you see, it's trying welcome 123, complex, testing, and bingo, here you go. See, it found your password. It said login is testing and the password is password 123, and as soon as it found the password, it actually stopped the attack. It says status attack finished. Perfect, right? That's what we wanted to showcase, that you can easily get your password. If you're keeping an easily guessable password, then it's much simpler for a hacker to try different combinations and or use a dictionary attack where the attacker is trying to use the words that are in the dictionary or in the text file that I just showed you, and then try different combinations using that. And here, as you can see, the attacker was able to log in with the username as testing and password as password123, which is the right password that we kept. So guys, very important, always keep complex passwords. Don't keep easily say guessable passwords. So thanks for watching. Hi folks, welcome back. It's time to take a look at another interesting type of attack, which we call MITM, or sometimes we say it man in the middle attack. Now, as the name suggests, man in the middle, right? There is somebody who's actually sitting in the middle, right? So this is where we are saying there is a user 1 who's happily talking to user 2. So this could be a client and a server, right? So what MITM attack does, the hacker comes in between. So if you see, there was a communication taking place between user 1 and user 2. What happens? Hacker comes in between and the entire network traffic is diverted through the attacker. So instead of going via this network route, it would start going through this. So user 1 thinks that it's talking to user 2. Actually, it's talking to the man in the middle or the hacker. User 2 thinks that it's talking to user 1, although it's talking to man in the middle. So this allows the hacker to get control of the entire traffic. The hacker can actually view what is happening, what messages are being sent, what data is being transferred over the network. Not only that, the hacker can even intercept. The hacker can delete, the hacker can even modify the data. So that's why it's really important that you should really protect yourself from a man in the middle attack. So let's take a look what it is. So as I said, it's man in the middle. So the guy is intercepting the communication between two parties in order to steal or manipulate data. So the purpose why a hacker would come in the middle would be either to steal the information, as I said, because whatever data you are exchanging between the client and the server, either the hacker is there to steal your data or as part of the data theft, or the hacker is trying to manipulate the data. Let's say you're transferring some money. So the hacker will try and manipulate it, try and increase it by 10x, right? So this is where it is trying to increase or to manipulate or to change the data. Okay. So then it also says the man in the middle attack is actually quite related to the eavesdropping on the unsecured wireless networks, compromising the routers or the devices. So what exactly is eavesdropping? So eavesdropping stands for, it's basically a term that we use in cybersecurity. Eavesdropping stands for intercepting, deleting, or modifying the information. That's what is the purpose of man in the middle. And as we just saw here, the attacker positions themselves between the two parties. So here user 1 was happily talking to user 2. What happens? The attacker comes and the entire network traffic starts getting diverted through the attacker. So the attacker is positioning himself or herself between these two parties. It's very difficult to detect. Why it's difficult to detect? Because user 1 doesn't know that it's being attacked, and user 2 itself doesn't know that it's being attacked, right? Because user 2 thinks I'm talking to user 1, user 1 thinks I'm talking to user 2, although the traffic is actually getting diverted through this attacker, right? So it's sometimes very difficult to find or to detect it. So who are the common targets? Definitely some financial institutions, e-commerce sites, social media platforms. A lot of social media platforms are normally attacked by this mechanism. Then what's the prevention? So as we studied or will be studying further in our lessons, it is through HTTPS. So you should always go for data in transit encryption. So you have data at rest encryption, but you have data in transit encryption. So any data that is traveling over the network, this should always be protected or should always be encrypted via TLS or HTTPS protocol, as we call it. So it's very important that you have secure communication. And you should regularly update your software and firmware and avoid unsecured network. So you should never have unsecured wireless, because that can anytime be attacked by the hacker. And so let's say if you are actually attacked, what's the remediation? The remediation is that you should really report the incident to the appropriate authorities. Let's say you are working in a financial institution and you observe that you are say a victim of a man in the middle. So you should just go and approach your authorities. You should tell them so that they can secure any compromised accounts or system. Normally it's more of that you should isolate that system, and then you should the authorities would actually work on to secure your compromised accounts or the systems as well. So I believe you've got good understanding about man in the middle attack. It's very important, guys, that you should know about MITM or man in the middle. Thanks for watching. Hi folks, welcome back. So in this video we will take a look at an MITM attack, or a man in the middle attack, using ARP poisoning. So let's take a look how it is done. So what you need to do is you need to go to root terminal emulator. You need to give your root password. Why we are doing this? Because we need to run. There's a utility called etcap. So the etcap has to be run in graphical mode. So we just say etcap -G. It will come up with interface, a kind of a graphical interface, which says sniffing at startup, primary interface ETH0. You can just pick, yes, it is ETH0. We want to sniff at this specific interface. You say accept. So once you say accept, you'll see that it says started unified sniffing. And then what you need to do is you need to click on the search icon, which scans for the hosts on this net mask. So in our case, let's say what it found. So if you go back to host list, you can see that this is the IP address that it found, which is 192.168.64.1. Now this is my Kali Linux machine. So if I go back to my original machine, or my actual Mac server, or it could be your Windows server, you can actually use something like a Wireshark. So Wireshark is nothing but it is used for sniffing network packets. It's normally used by network administrators. You can easily download it from the internet. It's freely available. And what Wireshark does is it tries to check the traffic on a specific interface. So if we just quickly look at what we have on 192.168.64.1, so we can see this is a match, right? So this interface, which is bridge 100, maps to 192.168.64.1. So if I click on it, and you will see that it says live capture is in progress. So there's nothing happening here. It's all good. Now what I'll do is we'll start our attack. So what we'll do is we will add this interface to the target. So you can see that the host 192.168.64.1 has been added to target. Then I go to the MITM menu, which is man in the middle. I'll say ARP poisoning. So what ARP, first of all, what is ARP? ARP is nothing but it is address resolution protocol. Now what happens, every computer maintains an ARP cache, right? And that what it would have is it would have the IP address of the target machine, and it will also have the MAC address of that target machine. So what ARP poisoning does is it will start diverting the traffic towards itself. So if you have to go to 192.168.64.1, what Kali Linux would do, Kali Linux would start saying, hey, I am 192.168.64.1. Come to me. I'm the one. So the user one thinks that it's actually talking to 192.168.64.1, but it's not. It's actually going to Kali Linux, which is 192.168.64.2. So if I quickly show you here, if we quickly take another emulator quickly and we say if config, so you can see the Kali Linux IP address is 192.168.64.2. Right, perfect. Now what I do, I've added this to the target host. I go to MITM menu and I'll say ARP poisoning. So it says sniff remote connections and poison, and we just simply say okay. Right, now you will see the magic. If I go back, you'll see the traffic coming here. Right, previously there was nothing here. Now we've actually started this ARP poisoning. So it's actually sending this traffic onto this interface, saying that hey, I am 192.168.64.1. Please come and talk to me, and this is my MAC address. You need to come and talk to me, right? So you'll see that if you try and see the details, you can even actually grab the details here, and it will all this traffic starts coming here. Okay, and after some time, you will notice these kind of messages start appearing. Just take a look. So many ARP messages. And if you see, it's asking for different IP addresses. Who has 192.168.64.48? This is a normal thing, right? Because the computer is asking who has got this. But if you actually see, everywhere we are telling that, hey, I am 192, you need to go to 192.168.64.2. So basically, any request that you're making is automatically being sent over to the Kali Linux machine. If you see, the sender IP was here, the sender IP is 192.168.64.2, right? If I check anywhere, you'll see it's actually pointing everywhere to 192.168.64.2. So here the sender is 192, and in certain cases you'll see the target is also 192.168.64.2, right? So this is what we call is ARP poisoning. So basically you have poisoned the ARP cache, right? Because all we are trying to divert the entire traffic onto the Kali Linux machine. So here, if you see, so previously there was nothing happening, right? As soon as we started this ARP poisoning, all the traffic is actually getting diverted to 192.168.64.2, which is our Kali Linux machine. So this is how the ARP poisoning takes place, and it is one of the forms of MITM, or man in the middle attack. I hope you liked the video. Thanks for watching. Hello and welcome. It's time to take a look at another type of attack called the SQL injection attack, or also known as SQLI, which stands for SQL injection. So as the name suggests, it's something related to SQL. So what is SQL? SQL is basically a structured query language. If you guys are familiar with databases like MySQL, Oracle, SQL Server, over there, we normally use the SQL statements, and the SQL statements are in something like this, like you would say select star from the table name and where you give the condition. Just imagine if you are on a login page of a website, right? So normally a login page of a website would have a username and a password, right? So ideally what you would do is you would give a username something like admin, and you give a password, and then it allows you to enter the website, because it checks against the database that what credentials you are supplying are correct or not. Now this is where a hacker tries to use the vulnerabilities inside the website if it hasn't been programmed properly. Especially talking about PHP, we will have a look. If you are keeping your code that is vulnerable to SQL injection, then the hacker can make use of it. And how the hacker makes use of it is, the hacker will try and give something like a condition, something like this, which says or 1 equal to 1. So all we are saying is, this is that kind of a condition which is always true, right? So if you are saying employee is equal to, say, admin, and you don't know the password, and if you specify that the password is something and you give or 1 equal to 1, so even then, without knowing the password, you would be able to enter the website. So this is called a SQL injection, right? You are exploiting the vulnerabilities in a website. We will take a look in a demo, and I will show you that how easy it is if you haven't coded your website properly. So a SQL injection, it is a malicious SQL, a structured query language statement that are inserted into the input field of a web application to manipulate or exploit the application's database. So as I told you, either you would be using something like select star from table name where username is this, password is this. If you don't know the password, you can inject something, a code, something similar to this, which is always true, which will allow you to enter the website. So it takes advantage of the improper input validation and lack of proper sanitization of user inputs in the application code. It's again, as I said, it's very important. If your developer is not following the best practices, then you can be prone to SQL injection attacks. The attacker aims to manipulate the SQL query executed by the application's database to gain unauthorized access. Very important, right? You are manipulating the SQL query. So you have an idea that you would be using something like a select star from table name where username is this, password is this. So you're just manipulating that and adding something like this kind of a statement, which is always true, right? So normally where you would use, as I said, it was normally used on login forms, search bars, comment sections, and you can try and get or retrieve the data from there. So adding malicious code after the input data using Boolean logic to manipulate the queries, and we will see in an example as well. So this is kind of a Boolean logic you are adding. You're saying or 1 equal to 1. It can lead to data breaches. Yes, because even without having authentic details, you are entering a website. You're getting the details out. So you can have access to the unauthorized access to the systems. You can have exposure to the sensitive information and even potential system compromise as well. So most of the data breaches that take place, they actually take place through the SQL injection attack. So very important that you should be aware of it. Okay, as always, we always talk about prevention. What's the way to prevent? Parameterized queries. Always do parameterized queries or prepared statements. Use bind variables in your SQL statement. And I'll show you in the next video how you can use that. So if you use parameterized queries or if you use prepared statements, then a hacker can't come and exploit these vulnerabilities because it's a prepared statement. It's a specific statement that the database server is looking at, right? So even if you amend the code, it won't work. So that's very important. And you can do some kind of input validations as well, that or sanitization. You can do put some checks as well. Like here, I can put some checks. If the value I'm entering, is it a specific character or alphanumeric character? It shouldn't be quotes, single quotes, and all these or conditions. So you are preventing your website from getting a SQL injection attack, right? So organizations should prioritize educating the developers. Very, very important. Here, it's pretty simple. So database servers are quite intelligent, but if your web application is not that intelligent, then you are prone to SQL injection attacks. That's why it says the organizations should prioritize educating the developers. So, and they should continuously monitor and secure the application against such attacks. So very important, guys. In the next video, I'll actually show you a demo where we will show you how a SQL injection attack is done. So keep watching. See you in the next video. Thanks for watching. Welcome to a very interesting demo on SQL injection or SQLI. So all you need to do is you need to log into a website, vulnweb.com, as I have done it. So if you read about it, it's actually a website created by Aquanetics, and it clearly says this site hosts intentionally vulnerable web applications. So what they've done is they've actually intentionally created some web applications, right? And these are intentionally created vulnerable web applications where you can actually practice your SQL injection attacks. It's all part of ethical hacking and just for educational purposes. It clearly says that's just for manual pen testing or educational purposes, right? So what we will do is we'll go to one of these and let's say we pick Aquat, right? So if you pick Aquat and if you go to the sign up page, you'll see that it clearly says the username is test and the password is test, right? So if I give here username as test and I give password as test, it allows me to log in, right? So let's log out of it. Let's go back to sign in. Let's try something different. Let's try test 1, 2, 3. Does it allow me? It doesn't, right? Now comes the thing how we can create SQL injection for this. Okay, let's take a look. So what happens, what it says is that if a developer hasn't used some kind of a prepared statement, then the kind of statement they would have put here is like how the database would be taking it is, or how the developer would have coded it would be select star from users where name is test and password is test, right? So we all understand that, okay, username is test, password is test, and it should go fine. But what we are going to do here is we are going to create a injection attack. And in that, what we do is, let's say we don't know the password. Okay. We are a hacker. We don't know the password. Now I need to inject that kind of code, which is always true. So if you see, if I remove this test bit here and these two single quotes, and if I actually take this bit from here to here, which is saying single quote, so I'm putting this entire thing in single quotes, it says or 1 equal to 1. So this condition is always true, right? So or 1 equal to 1 is always true. So let's try and see the magic. If I copy here, I go back to my website, I give the username as test and password as the one that I copied. So I don't know the password, right? I'm just giving a string like or 1 equal to 1. Bingo. I have actually entered the website. See, if the way it was coded was not done properly, then your website is so vulnerable. Even without knowing the password, I can enter the website, right? That's one thing. Now let's quickly go back to World Web, and in the same accord, if we look at the learn more on the topic. So if you go into this, it's a very good explanation they have given how you can prevent SQL injection vulnerabilities especially in PHP applications, because PHP on the web is more popular. So they have actually given you entire way. So it clearly says to prevent SQL injection vulnerabilities in PHP, use PHP data objects, which we call the PDO, and you create parameterized queries, are also called the prepared statements. It's very simple. So all you need to do is you need to take a variable, and inside that variable you give your statement, like select username from users where ID is this, and you always use the bind variables. So it says it should be preceded with colons and placeholders. Then you simply create a prepared SQL statement. So first you prepare a query, then you prepare a prepared statement, right? And then you bind the parameter to the prepared statement, and then you execute the query and you fetch the result. So if you are using something like a prepared statement, there is no scope for any hacker to go and manipulate the code, which we just did. Because in the previous scenario where we looked at it, or where we hacked into the website, it was a very simple query they had put. The developer had just simply put select star from users where username is test and password is test. So we manipulated that and added something which is always true. We added or 1 equal to 1. But here they are saying, guys, if you are a good developer, you need to write secure code. Your website should be really secure. That's why you need to use prepared statements, and only then you can avoid any kind of SQL injection attacks. So with this, we come to the end of the video. Thanks for watching. It's time to take a look at another important type of attack, or I'd say very, very popular type of attack, which is called DDoS, DOS, or denial of service attack. So as we always say, look at the root word. The root word for denial of service is deny. Deny means you are not allowing, right? So you are not allowing a service to work. So that is what happens in a denial of service attack. So if you see here, there's a bot master or an attacker, and the attacker is sending the launch commands to a botnet from a command control server. And from here, you are creating a lot of hundreds of infected hosts. And these hundreds of infected hosts are trying to create a lot of traffic on your website. And this will try and overwhelm your web server, creating a lot of traffic so that even your service, normal service, won't be available. And this is what we call denial of service attack. So the denial of service attack aims to disrupt the availability of a website or online service by overwhelming it. Overwhelming means that you are sending a lot of traffic. If you see, there are hundreds of botnets, hundreds of infected hosts. They are sending a lot of traffic onto the victim server or the website. So you're overwhelming it with a lot of traffic requests. You normally flood a website with traffic. You exploit the vulnerabilities in the software or use botnets to launch coordinated attacks. As we can see in this diagram, you're having hundreds of botnets which are actually targeting a specific victim or a specific website, a specific web server, and you're flooding it with traffic. Sometimes they even use ping commands, that you're pinging it, 1,000 say commands coming at one go to ping it. The other important type is the distributed denial of service. We call it the DDoS. And in modern computer systems, that is what they use. Distributed denial of service attack, which uses multiple system or devices to launch the attack, which becomes really difficult to mitigate it, because the attack is not coming from one direction. The attack is coming from all different directions. It's a distributed attack happening on your website or a web server. And yes, it can result in financial losses. Obviously, that if you let's say your website or your web page is not available, your clients can't reach you, then you are going to have financial losses, right? And it also causes damage to the organization, the reputational damage to the organization. And yes, sometimes in the past, what the hackers have done is they have done to divert the attention from a bigger attack. Let's say the cyber criminal was planning a big attack. Just to divert your attention, they will just overwhelm a specific web server so that all your IT workforce is looking at that. But because they have diverted your attention, they start attacking or start doing much bigger attacks, right? So it helps the attacker to distract or divert the attention from other cyber attacks to create a cover for the data theft, right? So what's the prevention? The best way to prevent is traffic filtering and access controls. So very important, you have your proper firewalls in place. You should have, say, software-based firewall. You should have hardware-based firewall. You should have proxy servers. So all these are quite important for preventing a denial of service attack. And don't worry about all these. In forthcoming videos, lessons, we will be learning at length about what is a firewall, what is a proxy server. We'll study all this as well. Okay, and as always, we always talk about the remediation, like how can we remediate it. In the event of a suspected denial of a service attack, it's important to report the incident to the appropriate authorities, and you should take steps to restore the service and prevent future attacks. So as I said, it's very important that first you need to restore the service, because your website, your say a business has gone down just because of that. Let's say you are a shopping website. Let's say you are amazon.co.uk. So apart from the reputational loss, you are also having financial losses because people are not able to buy products on your website. So that's why it says you should first try and restore the service. And for future, as I said, very important, you should have strong firewalls, strong proxy servers in place to prevent any kind of denial of service attacks. Very important type of attack that you should know as a cybersecurity professional. Thanks for watching. Okay, so as the world is changing, so are the hackers, and the hackers are becoming more smart. And this is where a new term or new type of attack comes into picture, which is called cryptojacking. So it comes from two words, crypto, as we know about the cryptocurrency. Yes, I'm talking about bitcoins here. And jacking comes from the word hijacking. You must have heard the term where we say a plane hijacking took place, right? So it's the same way where you are hijacking a plane. Here in this case, an attacker is hijacking your computer system. So let's take a look how it works. So as it says in step 1, this is the attacker. The attacker gets the malicious code. You can think of it like a malware. So let's say an attacker has created a malware, and that malicious code or the script on the website is sent over, right? So you are the victim. So let's say you are the victim here. So you probably go and visit that website, you download some code, and what happens is your device begins to start mining without your knowledge. So you are not even aware of it, but the hacker in the background is using your computer, using the resources of your computer, your CPU, your memory, your power, and mining the bitcoins. And when the data block is solved and added to the blockchain, the attacker receives a reward. So attacker is making money out of you, right? And obviously you are not even aware of it because you are the victim here, right? So let's take a look. So what happens in a cryptojacking? As I said, it's an unauthorized use of a computer or device's resources to mine the cryptocurrency. So here the attacker is using your system to mine cryptocurrencies for him or her. They normally inject malicious code into the website, or they will use the power of, say, phishing, so that you click on that specific link and this malware or malicious code gets downloaded to your system. And cryptojacking can occur through infected websites and malicious ads and compromised software or phishing attacks. As I just said, let's say it could be a phishing attack. The attacker is just sending you an email, an infected email. You click on it and you download the malicious software. The goal of cryptojacking, as the name suggests, I told you, crypto stands for cryptocurrency and jacking, hijacking. So to generate the cryptocurrency for the attacker. Yes, very important. You as a victim don't even realize that your system is getting used. How you would come to know is you would notice some kind of a slower performance. Definitely, because your resources of the computer are getting utilized. The attacker is using your CPU, your memory, and you will notice increased power consumption. You will have overheating. You will see your laptop, your system is really getting overheated. Why? Because this is using intensive mining process in the background. And attackers often leverage the botnets. So it's a network of compromised devices. As we saw in the example of denial of service attack, where they were having botnets, which is nothing but loads of hundreds of compromised devices. And they can distribute this cryptojacking malware to a number of devices. And it can affect various devices. It can affect computers, it can affect smartphones, it can even affect tablets, iPads, even Internet of Things devices, IoT devices as well. And as always, we always talk about the prevention, how you can prevent cryptojacking. To prevent cryptojacking, users should always keep your software up to date. So always apply security fixes. So wherever possible, always apply security patches and use reputable security software, antivirus, malware scanning, and be cautious when clicking the links or downloading the files. Hi folks, welcome back. I'm quite excited to start our journey into learning the different types of hackers. And the first type of hacker that we are going to learn is a white hat hacker. Now, what is a white hat hacker? A white hat hacker is basically a computer security specialist who uses their expertise in ethical hacking. Now, this might be a new word for a few guys. What is ethical hacking? So I always say, look at the root word. The root word here is ethical. Ethical, the root word is ethics. Ethics means your moral principles. So you as a person knows what is morally right and what is morally wrong. And you have been brought in to identify and fix the vulnerabilities in a computer system. Now again, for a lot of folks, they must be understanding what exactly is this word. So a vulnerability means a security gap, or you can say a weakness within your IT system that can be exploited by the hackers. So you are here to help and understand what is the security flaw within my company or within my IT system. They operate within legal and ethical boundaries. Very important, guys, that these are fully legal practices of using ethical hacking. So you can employ an ethical hacker or a white hat hacker. And the good thing is that they are working with the permission of the system or network owner. So you can think of it that they already have got the permission to hack. What it means is, let's say I'm the CTO of my company. I'll be employing these people or the white hat hackers and asking my security guys or my network admins to give them the right access, so that they can help me understand the security weaknesses within my company. As I said, they find security weakness in the system and report them to the owner, right? Very important. You're not only just looking at the security weakness, but you have to report them back to the owner, because that's the whole aim of this whole exercise. We need to understand what is the problem, where are the security gaps. White hat hackers are also known as ethical hackers. Now, a lot of times within cybersecurity, we use the term ethical hacking. So ethical hacking or white hat hacking is one and the same thing. Or you must have heard the term pen testing. Now, what does pen testing stand for? Pen testing is nothing but penetration testing. So similar to ethical hacking. Another key important point is you perform security audits and pen testing in order to identify the vulnerabilities. Now, sometimes what happens, a lot of times your companies would be audited, right? You can either have an external audit, or a lot of times what companies do, they perform an internal audit. So before, let's say an external audit comes to you, you would actually get an internal audit done just to understand that if tomorrow, say an external audit is done, you are fully prepared. So that's why as part of the internal audit, you will employ these guys and they will help you understand the security weaknesses. Now, you might ask, okay, but what kind of skills this guy needs to have? It's pretty basic, right? You need to have good understanding of your computer systems. You need to have very good understanding how a computer works, but on top of it, very, very good understanding of networks. And that's why you'll see future in the future lessons, we'll talk a lot about networks and deep dive on that. And obviously, they need to have a good know-how of hacking tools, because there are so many hacking tools available in the market. What a normal hacker or a black hat hacker, which we'll understand in the next video, would be using. So you as a guy, as a nerd, as a computer geek, should have understanding of those hacking tools. It's basically, it's all built on, you should have strong ethical code and be committed to use the skills for greater good, right? You are not causing any harm to anybody. All you are doing is you are hacking the system just for the greater good of that company or the organization. Quite important, guys. Sometimes people ask, okay, I want to become an ethical hacker. What should I do? There are a couple of certificates or certifications which are available in the market, which is CEH and OSCP. So which is the Certified Ethical Hacker course or certification, or Offensive Security Certified Professional, which is OSCP. Now, to just quickly make things more, I would say, interesting, let's quickly take a quick look at the famous white hat hackers. So I was just Googling it, like who are the famous white hat hackers, and you'll be really surprised that there are quite a few folks that you must know. It's Tim Berners-Lee. So guys, Tim Berners-Lee was the guy who was the inventor of World Wide Web. The WWW that we know today, he was the guy who invented World Wide Web. So Tim Berners-Lee actually started as a white hat hacker. Another very important guy, Steve Wozniak. Now, a lot of people know Steve Jobs, but maybe people don't know Steve Wozniak. So Steve Wozniak was also a peer of Steve Jobs. And what they did, basically, both of them sold blue boxes to the classmates in the college. And from those blue boxes, they moved on to bigger and better things. So what they used to do was they used to basically hack the phone system so users can make free long distance calls, right? So like these are the guys who have made their name, and they're quite famous. And rest of the names are here, like Kevin Metnick is there, Shimamura is there, Jeff Moss, big names. So you can always Google it and you can find this information. So coming back, just to quickly summarize, your white hat hackers, always remember, are doing things within your legal boundaries. You are allowing them the permission to work on your system. They are here to identify the security gaps or loopholes in your organization. And it's completely legal, completely ethical. Thanks for watching. So after taking a look into a white hat hacker, it's time to take a look into a black hat hacker. What is a black hat hacker? So basically, a black hat hacker uses their technical knowledge and skills to gain unauthorized access to the computer systems or networks for malicious purposes. Now, always remember, we are talking about bad guys here, right? So as a white hat hacker, I told you that you are being given the permission or you are being given the authorization, but not for these guys, right? So they are trying to enter your territory unethically. right? And they are trying to gain unauthorized access. Unauthorized access is that an access which I haven't allowed, but still they try to hack into my system. And they use it for their malicious purposes. They are not doing for good, right? What the white hat hacker was doing. So they use a variety of tools and techniques. And as I said, there are so many hacking tools available in the market, and we'll see some of them. So they are the guys who use different hacking techniques, tools, and they are they have very good knowledge of networks, computer systems, various tools, and they will try to come into your system without the permission of the system or the network owner. So as I said, you're not authorizing these guys, but these are the bad guys, and they are trying to enter your system. They may steal sensitive information. So just think about, you have databases where you are keeping all your PII. PII is like personal identifiable information, like your credit card numbers, social security numbers. So these are the guys who will try and steal that information. They can always install some malwares. So malware is nothing but you can say a software which is actually made to cause harm to the computers. They can even write some phishing websites. They can try and steal your passwords, and they are there to cause damage to the system or the network, right? And black hat hackers are motivated by personal gain. Now, if you ask about personal gain, it could be something like, it could be related to an insider threat. There is, and say, an insider, database administrator, security admin, or a security expert who wants to take this route of doing what the bad guys do, right? Or a black hat hacker could be motivated by financial gain. So he or she is a type of a guy who's looking to make some money, to steal important information, to steal sensitive information, and make some more money. Or it could be related to making some political or social statement as well. So there could be different reasons. And so it's basically, when they study, they look at, okay, what's the reason for becoming a black hat hacker? Some might say, oh, it was an insider who was already working in the organization. Others are more kind of guys who want to make financial gains. And you'll see most of these actually fall in this category. And they may actually work alone, or they can work as part of criminal organizations. So there are several criminal organizations within the whole world who can employ these black hat hackers, right? So they have made their name, and a lot of these criminals know about these people, and they can employ to cause harm to other companies, to big banks, financial companies. Black hat hacking is illegal. Please note it down. This is illegal. What we studied in white hat hacking, I told you, it is ethical and it is fully legal, but black hat hacking or a black hat hacker is illegal, and they can result in serious consequences, including fines and imprisonments. You can be sent to jail if you are caught working as a black hat hacker. Always remember. They may also use exploits to take advantage of unpatched vulnerabilities. Very important point. I told you that what is a vulnerability? It is nothing but a weakness or a security gap within your IT system. Now, these are the guys who try and focus on your security gaps, right? And they will try and exploit those gaps within your software and hardware. That's why if you see a lot of big companies like Oracle, which is in databases, Microsoft for SQL Server, they always come up with patches. All they are doing is they are trying to patch those security flaws which are there in their software or database. And black hat hackers often have a deep understanding of computer systems. Just like the white hat hackers, they should have very good knowledge of computer systems, of the networks, and as I said, different hacking tools they should be aware of. Now again, let's take a quick look at various black hat hackers. Now if we just Google and just say top 10 black hat hackers, you'll come up with a lot of these, and this is like an amazing guy. It's Kevin Mitnick. If you read about him, he was the most wanted criminal, cyber criminal. He was the most wanted guy by FBI. Why? Because he stole millions of dollars of corporate secrets from IBM, Motorola, telecom companies. He was actually sent to jail twice, and now he's actually works as a computer security consultant. It's a different story. Now, another quite popular guy, Vladimir Levin, a Russian hacker, right? So now this guy, he actually accessed accounts of several large customers, especially of Citibank, and he stole something like 10.7 million US dollars. Then you have another guy, Matthew Bevan and Richard Price, and they were like 21 and 17 when they broke into military computers. So just think about these guys, so young, but they are using their skills into doing these things. Then another quite popular one is Mafia Boy. So if you really see, they used distributed denial of service. So now you might remember we talked about DDoS attacks or distributed denial of service attacks. So just imagine these guys are using the same technologies that we've learned, and they actually took down major websites like Yahoo, FIFA, Amazon, eBay, CNN. Just think about the kind of damage they would have done. And there are quite a few more. You can always take a look at the list. So if you go back and we quickly summarize. So remember, black hat hackers are the bad guys. Whatever they are doing is illegal. They can try and why they are doing it. They could be doing it for their own personal gain. They could have a financial gain, as we saw some cases, or it could be driven by some political or social statement they want to make, right? And if you are a black hat hacker, remember it is illegal and it can lead to fines, but most importantly, you could be sent to the prison. So always remember, clear distinction between a white hat hacker, who are good guys, black hat hacker, bad guys. Thanks for watching. Okay, so after taking a look into what is a white hat hacker and what is a black hat hacker, it's time to take a look into a gray hat hacker. Now, who is a gray hat hacker? So basically, a gray hat hacker uses their technical knowledge and skills to gain unauthorized access to the computer system or network for a variety of reasons, and we'll see that, right? So just remember, with white hat hacker, you were authorizing that person. With a black hat hacker, we clearly said these are bad guys, so they are using unauthorized access. Very similar to a black hat hacker, a gray hat hacker is also gaining access, but in an unauthorized way, which is you are not allowing the access, but the person is still trying and hack into your system. Now, why would that be? Remember, very important key difference between a black hat hacker and a gray hat hacker is there is no malicious intent, right? So this guy is not here to steal money, right? This guy is not doing it for his personal gains, right? What a black hat hacker or a bad guy would be doing. So this guy is here to tell you what security flaws do you have in your company or your IT system. So they operate in a legal or ethical gray area. It's very important, guys. If you think in terms of from English point of view, if we just forget cybersecurity for a moment, what is a gray area in English? So a gray area is basically a situation that is not clear or the rules are unknown. So that's why we always say it's a gray area, right? I can't really say that, or I can't just simply say this is right, this is wrong. It's a gray area where I'm not certain, right? So they operate in a legal or ethical gray area as their action may not always be authorized by the system. Very important, right? They hack into systems to test their own skills. Now, it could be that they want to just test their own skills. Let's say a person thinks, oh, let me try and hack into Facebook and see how ethical hacking ability I have. But it's not really ethical hacking, but they're just trying to prove, or they're trying to prove a point about security, or they just want to tell Facebook that what are your security flaws, and you tell me about that. They can tell you that. So they can identify vulnerabilities and report them to the system or network owner, but without their permission. So again, they are finding the security flaws and they can report them. It's up to them, right? So let's say they hack into something. It's up to them whether they want to report it or not. But it's always remember, no company has employed you. You are just doing it based on your own understanding. So gray hat hacking can be controversial. So as I said, it's a gray area, right? So no one can tell you that this is right or this is wrong, and the situation is not clear. So that's why gray hat hacking can be controversial, and as it involves use of hacking techniques without explicit permission. Why it is controversial? Because a company is not allowing you to enter their system, but you're still entering their system. That's why we say it's controversial. Remember, gray hat hackers may face legal consequences. Now, it really depends on the company that you are targeting. They can always sue you or take you to the court because they haven't allowed you to enter their system, but you are still doing that, right? And some gray hat hackers may eventually transition to become white hat hackers, right? So we've seen cases in the past where a gray hat hacker has proven a point. He or she has shown, see, look at my security skills that I have. Why don't you just employ me in your organization? So a gray hat hacker can actually go ahead and become a white hat hacker. So basically get a good job, right? Now, again, as I said, it is not an accepted practice in cybersecurity industry. Because you folks are learning about cybersecurity, please remember you have to look into becoming a white hat hacker, not a black or gray hat. And a gray hat hacker is not an accepted practice in cybersecurity industry. Again, let's take a quick look at some of the gray hat hackers. Now, if you just look into the gray hat hackers, there are a few names like H.D. Moore, who was a creator of Metasploit. Then there is Adrian, but I simply love this guy, Khalil. If you Google this guy, this was the guy who actually hacked Zuckerberg's Facebook page. Why he did that? He just wanted to prove a security flaw within Facebook. Now, if you see, he's actually showing, it's a very interesting video. If you watch it, he's actually showing his 5-year-old laptop. He was saying that a lot of keys even in that laptop didn't work. So it was a very box standard laptop. He just used his own security skills to hack into into Zuckerberg's page. So if you can see, then they came to know about it, and see, if you see, it clearly says Khalil shared a link saying, "Dear Zuckerberg, first, sorry for breaking your privacy. And I had no other choice to make all the reports I sent to Facebook team." So he already sent a lot of information to Facebook team. Nobody took him seriously. Then he just went over and posted this on Zuckerberg's page. So as I said, he's a perfect example of a gray hat hacker. Always remember, if you are getting confused between a black hat hacker or a gray hat hacker, this is a gray hat hacker. Now, this guy had no malicious intent, right? He's not here to steal information. He's just trying to prove his point. Probably he wants a good job in Facebook, right? He's just trying, but that's not right. That's not the right way. He could have gone as a white hat hacker and tried over there, right? So all I want to say is, guys, clear distinction between a white hat hacker, black hat hacker, and gray hat hacker. Remember, a gray hat hacker is coming in without your prior approval. This is still not a legal practice. It is a gray area. The situation is not clear, and it is not an accepted practice in cybersecurity industry. Thanks for watching. Hello and welcome. Now it's time to take a look into another type of hacker, which is a hacktivist. So if you again try and break or try to get the root word, why would somebody coin a term like a hacktivist? It's a combination of a hacker and an activist. Now, hacker, by now we all know. What is an activist? So an activist is a person who campaigns to bring a political or social change. So please remember, these are the guys who use their technical skills to engage in hacking activities in order to promote a social or political agenda. Basically, they are here to bring some kind of political or social change within the environment. Hacktivists may be motivated by a range of causes. Now, again, it could be related to, so as white hat hackers, we know, okay, they were there working for the company. Black hat hackers are the bad guys. Gray hat hackers, they were trying to prove a point. Now, hacktivists are they also have a reason for doing it. So it's only because they're doing it for the people, or they just wanted to bring some kind of social justice, political activism. So political activism is nothing but a process of campaigning in public. Why they are doing it? Again, to bring a political or social change within their environment. Or there are a lot of activists who do it for environmental issues. Now, because of all this carbon in the or the fuel consumption that is there in our environment. So these are the people who are promoting that side of the things, right? So they would disrupt or protest against the government, corporate, or other organizations that they see as opposing their agenda. So they could be against anybody, right? They could be against a government. They could be against a particular company who hasn't done something right, or they could be against a certain other set of corporates as well. So don't think that they are here to steal money or something. Normally, they try and target big governments, right? Or they can target big corporates, big financial companies, or big organizations. Hacktivists often use social media and other online platforms, as we will see. They normally use social media, if you see. And they are also using a lot of online platforms to publicize their actions. And we'll see an example of WikiLeaks, Anonymous. Basically, they post everything on the website so that people can just have a look. Hacktivism can take several forms, and one includes website defacement. Now, what does this mean? So what does website defacement mean is that this guy or this group will hack your website, and on the very first page, or the first page of your website, they will put their own content, right? They will just add some rubbish, or they will just write specific things, why we have hacked you, what wrong you have done to the public. Or probably if they hack, let's say a government website, they'll just simply say what are the wrong things the government is doing. So that is called website defacement. And they could even do some denial of service attacks as well, right? So some kind of DDoS attacks they could do to prove the point, or they could do a data breach as well, as we will see in case of WikiLeaks, where some data breaches were done. So they were trying to get the data or steal the data. And hacktivist groups may operate anonymously. Now, sometimes they can just work openly. They can say, oh, I'm a hacktivist group, I'm working here. Or just to be under safe, or just to be under the blanket, they normally use or operate anonymously, right? As they won't tell their name, right? But they still keep on doing their work. Or they can use some online handles as well, like as we know in Twitter, Facebook, companies use their own handles. So they can just create a specific handle and they can work under that. And remember, again, it is illegal, guys. Being an hacktivist, maybe you are saying that, okay, I'm doing this for the people, but governments or the law still treats this to be illegal, and it can result in consequences which can be fines or even imprisonment, right? Always remember, this is something that is actually not allowed, right? So even if you are doing for the betterment of the public, but still it's still considered to be a cyber crime, right? Now we are learning cybersecurity, so please understand hacktivism is considered to be a form of cybercrime that undermines the rule of law. And perfect examples, if anybody asks you, are Anonymous and WikiLeaks, and we'll quickly take a look at both of these. So what exactly was Anonymous, right? So basically, Anonymous, as the name suggests, doesn't have a name, right? Anonymous. So they kept their identity secret. But if you read about it, so after Russia had invaded Ukraine, so they actually had a Twitter account. As I said, they have anonymous Twitter handles, and they had 7.9 million followers, right? And they simply declared a cyber war against Russia and against President Vladimir Putin. Since then, they have openly claimed responsibility for various attacks that have happened on Russia, right? So it's a perfect example of a hacktivist group, or which is anonymous. If you see their Twitter handle, they just simply say, guys, they're just talking about Vladimir Putin, that what wrong you are doing, and just put yourself in the shoes of Ukrainians being bombed right now. They're just clearly declaring a war against Russia, but this is a war which we call a cyber war, right? The next very perfect example is WikiLeaks, right? So WikiLeaks was a not-for-profit organization. It was created by Julian Assange, and you must have heard about this name. We'll quickly show you that. And it basically specializes and analyzes the publication of large data sets of censored or otherwise restricted official materials. So what they did, they actually openly published the documents, I would say secret military documents from US government onto their website. And since then, this guy, if I quickly show you, now you might remember Julian Assange, perfect example of a hacktivist, right? He's been in custody. He's been in home custody. He has faced several mental issues. He's been in UK for quite a long time. If you see the latest, like in January 21, he was denied bail. In December, the High Court in London ruled that he should be extradited to US because US really want him back. He's an Australian guy, but US really wants him back because he's actually gone ahead and published all their secret military information, right? And the latest was like in July 2022, it was announced that he's again appealing, right? So the thing is, I think by now we get a good clarity about who an hacktivist is. Always remember, hacker plus activist, a person, or you can say a group of people who are there to campaign to bring a political and social change. Thanks for watching. Okay, so now it's time to take a look at another type of hacker, which is a script kiddie. Now, the thing is that although Shakespeare has said what's in a name, but guys, there is a lot in a name. Now, if you go back to a hacktivist, I would say from the name, it suggests that it's a hacker who is an activist. Same way, when I talk about a script kiddie, can you just try and visualize about a kid? And we do have it on our presentation as well, right? So these are the guys, or these are the kind of hackers who don't have much knowledge, right? They act like kids, right? Because they simply use the pre-written tools. So they're simply using what is available on the internet, right? And without having much knowledge or without having an understanding how things work under the hood, they would try and launch attacks on computer systems or networks. As I said, they have little or sometimes no knowledge of their own, and they rely on pre-made tools to carry their attacks. So just imagine if you compare with say black hat hacker, white hat hackers. These are the guys who do have no knowledge or very less knowledge. But if you talk about a black hat hacker or white hat hacker, they are like, sometimes they are certified people. They know the art of hacking. They would have very good understanding of computers, networks. But these are just like kids, right? They may just simply download and use the hacking tools, right? Very important. There are humongous tools available on internet. If you just Google it, you will find lots of hacking tools. And if you start using those, then you just simply become a script kiddie, I would say. Because you're not even writing your own script, you're just simply downloading and using the scripts that are easily available on the internet. They are normally motivated by a desire to prove themselves. As I said, they don't have much. They don't want to steal money or something. They just simply just want to showcase that, oh, I have very good hacking skills. Or within their peers or friends, they'll just want to show that I'm the notorious guy of all, right? So just not much knowledge, but trying few things. Their attacks may be relatively simple and unsophisticated and may target low-hanging fruit. So normally we see that script kiddies won't just go and start attacking US government, or they would start attacking, say, military website. They just try low-hanging fruit, which means small companies, they just want to try it out whether their hacking skills work or not. And so they will try to find loopholes within the unsecured and outdated systems. They are not doing it. If you think about it, the tool that they are using does it for them. All they know is how to use the tool, but they don't know how the tool works. So actions can cause disruptions and damage to less secure targets. Definitely, because it is a kind of hacking. It can, let's say they are doing a website defacement, they are doing a denial of service attack. It can cause disruption at the end of the day. They normally operate alone. As I said, normally they are people who don't have much knowledge, and they just try to operate alone. Or it could be a group of friends who try and say, okay, let's try and just try and hack certain websites. And they may not have a specific agenda, right? As we said that with hacktivists, with black hat hackers, you had a specific agenda, but these guys, they don't have much hacking agenda. And normally a script kiddie can actually transition. So once they are fully matured, they start using the techniques, they get good understanding of the tools, they can become say probably a white hat hacker, or you never know, they could become a black hat hacker, who knows, right? So they can they can easily move to more advanced hacking techniques, right? And as I said, and the good thing about these script kiddies is that because they use pre-made tools, right, what is already available on the internet, it's easier to detect them. So if you think about the cyber governance team or the people who are working in cybersecurity, they can easily catch these guys. Why? Because they are just using pre-built tools, which is already available on internet, and everybody has knowledge for that. So it's easier to find these script kiddies. Again, an interesting look at what they can do. As I said, they can lead to denial of service attacks, right? They could cause social engineering or phishing attacks, right? Where they can manipulate the code, or more with the manipulating people, or website defacement. As we know, with website defacement, they could just change the contents of the website to what they want. And just some real world examples as we normally look at. In 2015, there was a distributed denial of service attack in UK, and police in UK arrested around 6 teenagers for allegedly using the DDoS attack. And they actually, again, used a pre-built tool, which is Lizard Squad's Lizard Stressor. So if you see, it clearly says that this tool enables the users to take websites offline for up to 8 hours at a time. Such a dangerous tool to use, right? So they didn't have any knowledge. They just simply used it. Then there was another Mirai DDoS attack, and there was about the Mirai botnet DDoS attack, where they simply just used another website, which is webstressor.org. As the name suggests, web stressor. So it is stressing your website or causing a denial of service attack. So bottom line clearly says script kiddies are unskilled but dangerous. Remember that, please. So again, to summarize, these are the guys who are hackers, but with very less or little knowledge how computer systems or networks work. They just simply use pre-built tools that are available on internet. So that's it for script kiddies. Thanks for watching. See you in the next video. Hello and welcome. I'm quite excited to start this journey on cryptography. So guys, please remember, if you are actually working in the field of cybersecurity, you will always be working on things like encryption. You will be talking about TLS or the transport layer security, SSL, and you'll be talking about digital certificates. So these are some of the key terms you will always keep talking. But have you ever wondered that what's the base of these technologies? So that is what we are going to learn today. The base for all these is cryptography. So, but what is cryptography? And the best diagram you can even think about in terms of cryptography is the one in front of you. So what cryptography does is, it says that if you are a sender and you are sending an information to a receiver, right? You need to ensure that that information is not sent in the plain text format. Why? Because just imagine that you are actually sharing your credit card details, or you're adding these details as part of a transaction at a banking site. Now, there can always be a man in the middle who can read, who can change these transactions. So that's why the base for cryptography is you start with the plain text. You apply something like an encryption. So encryption is nothing but you use an encryption algorithm. On top of it, you apply certain keys and you get a ciphertext. Now, ciphertext is your encrypted data. So if, let's say, there is a man in the middle and the man in the middle gets your ciphertext, they can't decipher anything out of it, right? They can't understand what that information means until and unless you actually decrypt it. So there are two terms, encryption, decryption. Decryption is nothing but you take your ciphertext and you apply the algorithm and also apply a key, which could be public-private key pair based on this, and we'll be studying all this as well, and so that you get back the plain text, right? So let's quickly take a look at what is cryptography. So cryptography is the use of mathematical concepts and rules to secure information and communication. So going back to this example, if you see what all are we going to achieve, what we want to achieve is we want to achieve a secure communication, right? It really needs to be secure communication. So whatever information I'm sending from sender to the receiver, it needs to be secure. But the key here is mathematical concepts. And when we study this, you will see that a lot of algorithms we talk in cryptography, like RSA algorithm, Diffie-Hellman, elliptical curve, these have actually been created by mathematicians. So, and the base for all these algorithms has been mathematics. So if you're really good at mathematics, then I would say this is the best field, like cryptography, if you want to really work on that side. So remember, cryptography is nothing but the use of mathematical concepts and rules. It's actually derived from a Greek word, kryptos. So when they coined this term cryptography, they looked at these different words and they came across a word which is in Greek mythology, it's kryptos, which means hidden. So anything that is hidden is called kryptos. And if you see, the information that you are sending from the sender to the receiver is also hidden, right? It's in the form of a ciphertext. Similar thing what we already discussed. So cryptography itself refers to converting. Remember, converting. You are converting the plain text into a ciphertext, right? And vice versa, right? It's not just that, right? So you convert the ciphertext back to the plain text as well, right? That's why it says converting plain text into ciphertext, and vice versa. What it means is converting the ciphertext back to plain text, and that is what we have shown in this diagram. Cool. So cryptographic techniques allow only a messages sender and the intended recipient to read the decoded content. So here we talked about the man in the middle, right? If a man in the middle comes somewhere here, they won't be able to understand what message you are sending because we have encrypted it. So encrypted is nothing but the plain text changes into something like a garbled text. For that person, it would be a garbled text. That's why it says it is meant for the intended recipient. So if A is sending the message to B, it makes sure that A is the sender and B is the receiver, and the message hasn't changed in between, right? So in the next video, we shall talk about the history of cryptography. Thanks for watching. Hello and welcome. So my dad always used to tell me, if you really want to go deep dive in a subject, then you should always start with its history, right? So let's do the same. So we are studying cryptography. Let's take a look into the history of cryptography, or how it started. So it all started from the early Egyptians, and it started with hieroglyphs. So hieroglyphs were nothing but a formal writing system used in ancient Egypt, which was used for writing the Egyptian language. So if you actually take a look here, it's actually a symbolic language. So if you see, if you had to send an A, you were actually using a symbol, right? If you had to send a G, you would be using a symbol. So if you are sending a hello message, then you would actually be writing it in symbols, which is, in a way, if you see, it's a kind of a hidden text, right? If you don't know what each symbol means, then you can't decipher what the message is all about, right? So if we move on, then came a very popular cipher technology, which was called Caesar's cipher. Now, the Caesar cipher has been so important, has been the base of cryptography. It's actually taught at schools, colleges, and a lot of universities as well, that what exactly was Caesar cipher. So the Caesar cipher was actually used by Julius Caesar around 58 BC, which is actually a substitution cipher that shifts the letters in a message to make it unreadable if intercepted. So if you see, we are actually, if you have to send an A actually stands for X. If you have to send an E stands for C. Or let's say if you have to do a hello, and we will do it in the next video, the H actually stands for E, right? Or I stands for F, right? It goes like that. So it is basically a Caesar cipher where all you are doing is you're shifting the letters by certain number. So like in this case, you are shifting from C to A. So either you could go forwards or you could go backwards, right? And we will take a look in more detail in the next video. Then moving on, we talk about polyalphabetic cipher. Now, if you look again at the root word, it has got poly. Poly always means multiple. So in Caesar cipher, you were just shifting your letters by a certain number, but polyalphabetic said that it was a substitution algorithm in which we used multiple substitution alphabets, right? So it was all about making the encryption algorithm more secure, I would say, and more complex as well. And that is what you will see if you see at the history. It started from very simple symbols, then we moved on to Caesar cipher. We were just shifting some letters by a certain number. Then came the concept, no, not one substitution would be enough. Let's do multiple substitutions. That is what polyalphabetic cipher was all about. Another key in cryptography was the Enigma machine. So the Enigma machine is actually a famous encryption machine which was used by the Germans during World War II. Now, this was something that the Germans came up when they had to send messages, important military messages, right? So the Enigma machine, if you take a look here, this is the Enigma machine. It actually allowed for billions and billions of ways to encode a message, making it incredibly difficult for other nations to crack the German codes during the war. And it was like the key to the World War II. Okay, then we moved on and we talk about public key cryptography. Guys, just remember, this is the key to the cryptography that we are working on today, the public key cryptography. Very important subject in cryptography, public key cryptography. Now, a public key cryptography is actually an asymmetric cryptography and is the field of cryptographic system that uses pairs of related keys. And we will come to know, you'll always see that when we talk about an asymmetric algorithm or asymmetric key, you will always have a combination of keys. You will always have a public and private key pairs. We call it key pair. So each key pair consists of a public key and a corresponding private key. And key pairs are generated with cryptographic algorithms which are based on mathematical algorithms or mathematical problems termed as one-way functions, right? So it's quite important that you should have a good understanding of public key cryptography. Now, if you move on and if you talk about today cryptography is being used everywhere, right? If you are today, say, going to the World Wide Web or to the internet, from the point you start or from the point you get connected, cryptography is in place. And we don't even imagine that this cryptography is all around us, right? When you do an HTTPS, www.google.com, from that point onwards, you are using cryptography, right? The HTTPS, S stands for secure. Which something means secure, it means you are encrypting some data and at the other end, it is getting decrypted. Right? And even when you are making transactions to the bank, right, you are giving your credit card information and all that stuff is actually protected. All your financial transactions are protected. Even the military data that has to be exchanged or the different governments that need to talk to each other on complex matters, for international security, that always happens on on this encrypted channel, I would say. So all I want to say is that cryptography started from early Egyptians, and it is still being used, and it's I would say a very important part of our lives today. So thanks for watching, guys. Hello and welcome. In this video, we shall take a look at Caesar's cipher. Now, as I told you in the previous video, that Caesar's cipher is really an important encryption algorithm. It's actually taught at several schools, colleges, and universities. Now, what exactly is a Caesar's cipher? So the Caesar's cipher was actually used by Julius Caesar around 58 BC, and it's based on a substitution cipher, which says that you need to shift the letters in a message to make it unreadable if it is intercepted. So let's try and understand that. So what Caesar's cipher says is, let's say you take the substitution as -3, right? So what you need to do is you need to go back that many number of times. So if we are at D, if you have to send D, you go 1, 2, 3. So which means that the D substitutes to an A, and that is what it clearly says. So if you see D, it substitutes as A, right? So same way, what we have done is we have taken an example of hello. And here what we are going to do is we are going to take the substitution as +3, right? So let's say you need to send H. So if we try and understand that, if I saying HIJK, right? So we have to go or advance it by 3 letters. So H, 1, 2, 3, right? So it means that H stands for K. And if we are going from E to say 3 letters, so it is 1, 2, 3, right? Which means H, this, so this is H, this is E. So H stands for K, E stands for H. So that is what you have. So if you keep on going it, you will see that this is what you get. You get a hello as cool. And same way, if you to if let's say you get the decrypted message as cool, now you need to get the encrypted message back. So what you need to do is you need to do it in a reverse method. So because it was +3, you go -3, right? So this K actually becomes your H. So if you see K, 1, 2, 3, it becomes your H. So if you are the receiver and you apply the decryption method as -3, then you will get its H's back. So what I want to say is that, let's say if you get this as the cipher text, right, and you are applying your decryption algorithm, then you are able to get the original message. So this is the original message, right? So that is what the Caesar cipher is all about. So let's take a look at the details. Okay, so the Caesar cipher says, please shift. It's also called a shift cipher. Is one of the simplest and most widely known encryption technologies in cryptography. So whenever we talk about cryptography, we always start cryptography with this Caesar cipher because it's the simplest and it is widely known technique. As I told you guys, it is actually named after the Emperor Julius Caesar, right? Who's believed to have used this technique to communicate with his generals. So whenever he used to send a military message to his generals or for his generals, he used to encrypt that original message with the Caesar cipher. And he used to apply this encryption technology, and so that the receiving party knows that that message has been sent by Julius Caesar, first of all, and the receiving party also was able to make sure that no man in the middle, or let's say the enemy, hasn't changed that message when it came across from Julius Caesar, right? So very important that it is actually named after Julius Caesar, and also it's used to communicate with his generals. As I told you, what we do in Caesar cipher is we shift each letter with a certain number of places, like we talked about +3, right? So you are shifting each letter with a certain number of places, right? So let's say we had to do a K or we had to do an H when we are sending hello, so H becomes K, right? So you're just shifting the letters by number of places. And here is the example. So if you shift the value, the shift value is 3, the letter A would be replaced by D. That's what we saw, right? So A is actually replaced by D, and B would become E, and so on. And that's how we got this. So here's an example how Caesar cipher works with a shift of 3. I gave you already and explained it to you. So that if you're sending hello, it becomes cool, right? So you shift by 3, right? Now, very important, guys, and I've already explained. That's why I always do. I've already done the explanation for you. So to decrypt the message, now let's say I'm the general working in say Julius Caesar's army. I get the messages cool, right? Now I need to decrypt it. So, right. So what it says is the receiver simply shifts each letter in the opposite direction, right? So if Julius Caesar had encrypted using +3, I would decrypt it using -3. It's not I will again apply +3. Then it would become some other text, right? To get the original message, I have to go backwards. So if you see, that's why we said +3 when we are sending and -3 when we were receiving it. That's why from Kur, I was able to get hello, right? So clearly says the receiver shifts each letter in the opposite direction by the same amount. So if it was 3, if it was +3 ahead, then it would be -3 at the back, right? That's pretty simple. The last, what it says, they would shift each letter back 3 places to reveal the original text. And what was the original plain text? It was hello. So just to quickly summarize, this is all about Caesar's cipher, which is based on Julius Caesar, how he used to send messages to his generals. The main or the key takeaway is that he used to shift certain letters by a certain amount, let's say +2, +3, +4, whatever it is, and the receiving party had to decrypt the message and had to go in the opposite direction. So if I'm doing a +3, they would do a -3 to get the message back. Thanks for watching. So in the previous videos, we studied what is cryptography. We looked at the history of cryptography. We even looked at the Caesar cipher. Now it's time to understand the various types of encryption. And the first one that we will study is a symmetric encryption. Now, as I always say, guys, always look at the root word. So the root word here is symmetric. So what does symmetric stand for? Symmetric actually stands for same. Right? Now let's try and understand what it means. Let's say you have an original text, which was, let's say, hello, right? And you need to send this to your receiver, right? What it says is you need to encrypt this using a key, right? Let's say we have this key, right? You use an algorithm, you use a key, and let's say that key was, in taking an example of Caesar cipher +3, right? So use the key and you get a scrambled data or the garbled characters. Now, when it comes to the receiver gets it as a ciphertext. What the receiver needs to do is use the same key. So the key that I used here, I need to use the same key here. So what I'll do is, let's say my algorithm says that when you're doing an encryption, you need to go forwards, and when you need to do a decryption, you need to go backwards. But my key here is the 3, right? The number 3, that how many times do I need to go up front and back, right? So if you see here, when I'm encrypting the data or when I'm decrypting the data, I'm using the same key, right? That is what is symmetric encryption all about. Now let's study it. So symmetric cryptography uses the same key. I think I've almost repeated this thing almost 10 times since the time we started our video. So symmetric cryptography, symmetric, same, similar. Remember that you always use the same key when you're encrypting or decrypting the data. Very important. The most commonly used symmetric encryption algorithm. So we will study a lot of, so there is one symmetric, then there is one asymmetric. In asymmetric, you basically use a key pair or a key combination. We call it public-private key pair, and we will take a look in the following videos. But what I'm trying to say here is that when you talk about symmetric encryption algorithms, then the key encryption algorithms, the most important encryption algorithms that are available are DES, which stands for Data Encryption Standard. Nowadays, we use AES, which is the Advanced Encryption Standard, and there is also Blowfish, right? So the symmetric cryptography is considered to be really fast because you don't have to get a different key pair on the say the sender side and receiver side, or use a different key combination to get your data. You're just using the same key, right? I'm also encrypting the data using the same key, and the person who's getting the message is also decrypting the message using the same key, because it uses less computation power. So it's pretty good if you think in terms of the World Wide Web, where we are talking to different parties. If we are able to use symmetric key, then it would be so good, but it has its own challenge as well. And the biggest challenge is key distribution, right? Now, let's say I'm sitting in London and this guy is sitting in say US, right? So if you just try and imagine, let's say we are sending this, how would the guy sitting in London know that I need to use this key, or I need to use a cipher code of 3, right? So the biggest challenge it introduces is key distribution. What it means is, how do I tell the guy sitting in US that you have to use this key? Either I could post that message, or I could send by certain ways. Now, if you just imagine, if you do that, then you're always prone to some man-in-the-middle attacks, right? So, and that's what the World Wide Web is all about. We have a combination, and we will study that. You always use symmetric encryption, you use asymmetric, and use a hybrid encryption as well. So, but since now we are studying symmetric encryption, so the biggest advantage of symmetric encryption is it is very fast, it uses less computation power, but that are its advantages. What are the disadvantages? The biggest challenge is key distribution. How do I share my key with the receiver, right? So as it says, it is necessary to securely distribute the same key to both sender and receiver without anyone else getting access to it. So it's quite straightforward, as I said. So the biggest challenge is you need to distribute it, but you need to securely distribute it. And we will see how it is done in the upcoming videos. And now it talks about what are the different use cases. So use cases are just simple. As you can see, I'm sending a hello, and I'm sending from sender to receiver. It's basically for securing the communication between two parties, protecting the stored data, and providing secure access to systems and networks. So if you want to provide secure access to systems and networks, we use asymmetric encryption. Like if you guys have studied Oracle, then we talk about TDE. TDE uses symmetric encryption, then SSH is based on that. So what I'm trying to say is there are a lot of use cases for symmetric encryption. But again, if there is a use case, you need to be aware of attacks as well. It's vulnerable to attacks such as brute force, where an attacker tries all the possible combination of keys. So the attacker knows that in symmetric encryption, the encryption and decryption keys are the same. So based on that, they can try a brute force, where they can try so many different combinations of keys going in one go, and they can try and break that. Now it says, yes, there are ways to enhance security, and symmetric cryptography can be combined with other techniques such as hashing, salting, key stretching, right? So that is quite important, and we will study all these features. What it is trying to say is, even though symmetric encryption is quite important and is actually used, but you can make symmetric encryption really strong if you do other techniques or use symmetric encryption along with other techniques such as hashing. You can do some kind of like a hashing algorithm. You can even use some salting and key stretching as well. And we will be studying these as well in more details in the upcoming chapters. So the message here is, we are studying symmetric encryption. Symmetric encryption, remember, and the last time I'm saying this word, symmetric stands for similar or same. So the same key is being used when you're encrypting the message, and the same key is used when you're decrypting the message. Thanks for watching. Okay, so in this video, we will try and understand symmetric encryption using a very simple example. Let's take an example of two folks, Joy and Aileen. Let's say Joy needs to send a message to Aileen. Let's see how it goes. Let's say Joy needs to send a message called hello to Aileen. And now we all understand by now that we can't send this plain text over the internet, right? We need to encrypt it in certain methodology. So let's say I use a key. This is my key, right? So I use a key and I basically encrypt this message using my key, and I send a message which is cool. Let's again take an example of the Caesar cipher, right? Let's say the H gets converted to K, right? And E becomes H and the hello message becomes cool, right? So here, this is my key. This is the key that I'm using. So probably I should say a +3 here, right? So let's say I'm using a key here, which is +3. Now, the thing is that when this message arrives to Aileen, Aileen knows that my encryption decryption algorithm is that I have to use the same key. And the same key here would be, I would say, she would be using a -3 here. Because as I said, there are two things always. You need to know your algorithm and you need to know your key. So the key here is 3, right? And the algorithm here is Caesar cipher. So if I apply that Caesar cipher on cool, we all know that it becomes hello. So the encrypted message cool, which was sent from Joy to Aileen, automatically becomes hello when the symmetric encryption or the same key is actually applied on that message. So the key takeaway from this demo was that we are using the same key to encrypt and to decrypt. Thanks for watching. Hi folks, so I believe by now you have got some good understanding of what is symmetric encryption. So as we said, in symmetric encryption, you are talking about the same key. So the same key is used to encrypt and the same key is used to decrypt. Now what we'll do is we will actually take a look into symmetric encryption and understand through a demo. So what this demo does is that first we will check the available encryption algorithms. We'll use the OpenSSL command and we'll do a list cipher commands and grep for AES, because AES is what is the recommended standard, and we'll look at, okay, what all different kind of algorithms that are available. Then we will create a file called hello.txt, and with the contents, simple contents, we'll just keep hello world. Then we will encrypt the file, and when you are encrypting the file and when you're giving a specific algorithm, the algorithm that we'll use is AES256 CBC, then it will ask you for the password, and the password that we'll use to encrypt is PA55WORD, right? And we will send the encrypted file to the receiver, because what we'll do is we will create two directories, sender, receiver, and we will just try to imagine that, okay, a sender is sending that encrypted file to receiver, and how the receiver will then decrypt the file. Okay, so let's take a look how it goes. So first of all, I'd suggest that you create two directories. One is sender and other is receiver. Okay, let's go to the sender. Right. So as a sender, first we want to check what encryption algorithms are available to me. So if I just simply copy this command, and you can do it with me when you are actually practicing at your end, just simply do OpenSSL list cipher commands and you grep for AES. So if you do that, then you'll see that all these different kind of algorithms will appear, like AES 128, CPC, AES, but we'll pick the best one, which is AES 256 CBC. Right. So what we do is the next thing, it says create a file called hello.txt with contents as hello world. Okay, so let's do that. Very simple. Just do vi hello.txt, and in this we give hello world, right? And our file has been created. Now our aim is that we need to encrypt this file. And to encrypt this file, we will use a simple command, which is again OpenSSL command. And we say OpenSSL encrypt. And in this, we are saying the encryption algorithm, which is AES256 CBC. In -in is kind of the input. What is the input? Input is the actual file. And what is the output? output file is the encrypted file.txt, which will be created. So let's see what it gives. And as I told you, when you're using this encryption algorithm, it will ask you for the password. So how the password that we'll give you is P855WORD. Okay, it asks again P855WORD, right? Perfect. So now your file has been encrypted. Now you just need to think, okay, you are sending this file to a receiver. So all you are doing is you will copy this encrypted file and you will send to the receiver, right? Okay, so now we go into the receiver. Let's say you are the receiver. You get this file and you first of all try and cat this file. You say, oh, this file is there. Let me try and read the contents. Oops, it's all garbled characters and says salted, which means that it has been encrypted. Now, what I need to do is I need to decrypt this file. And I told you in symmetric encryption, the key that is used to encrypt, the same key has to be used to decrypt it. Let's try first different mechanisms to break it and see if it works or not, right? So first we will try and decrypt the file. And in here, what I'll do is I'll first try and use a different algorithm. Let me try with AES, let's say 128 CBC, but using the same password. Let's see what happens. Okay, I'll give P855WORD. Just have a look. You get a failure, right? It says digital envelope routines and you get a failure. Clearly says bad decrypt. It means you're not able to decrypt the file because you're using something wrong. Now let me try another hack and let me try and use same algorithm but different password. So let me try a password as PASSWORD. Again it fails, right? So what it needs to, what it wants is same algorithm and same key or the same password that we need to specify. Let's try it now. So I give P855WORD. Perfect. So it worked. And now if I cat the decrypted file, amazing. So voila, you'll see that you get the decrypted text back. So the sender sent you a hello world message in an encrypted format, and now as a receiver you decrypted it, but for that you use the same encryption algorithm that the sender used and you use the same password. That's why you were able to get the file back. So this is a demo which shows how symmetric encryption works with OpenSSL. Thanks for watching. Hello folks, welcome back. So after studying the symmetric encryption, now it's time to take a look into asymmetric encryption. Now, as we studied symmetric, again, I'm saying symmetric stands for similar, but asymmetric is something that is not similar, which means it is different, right? So here we are talking about a key which is different between the sender and the receiver, right? And whenever we talk about asymmetric encryption, you will always remember that you're talking about two keys. We call it the public and the private key pair. Now here we are taking a quick example where Bob has to send a message to Alice. Now Bob sends a message called hello Alice. Now we know that we need to encrypt it using a key. As I said, there is a combination or there is a key pair. Let's say Bob sends the message using Alice's public key. Guys, always remember that if I am encrypting a message using Alice's public key, then there is no key in the world except Alice's private key that can be used to decrypt this message, right? So if you see, when this garbled characters or this garbled message comes over to Alice, Alice needs to apply her private key to get the message back, right? So always remember these key pairs, as they're called pairs, right? They are peers to each other. You can even say they are peers, they're companions, right? So they always work in pairs. If you're doing something with a public key, you do the other part with the private key. Or if you do first part with the private key, you do the second part with the public key, right? And we will look at all these different scenarios, but let's try and understand the theoretical part. So asymmetric encryption is a type of encryption that uses two keys, public key private key. Now let's try and understand that part, right? As the name suggests, public key. Public means something that is available to the whole world, right? If I have my key pair, if I'm generating my public private key pair, then I can distribute this public key to the whole world. Always remember, I will simply distribute it, right? But private key is something that is close to my heart. I always say private key is close to my heart. Never share. Never share your private key. Private key is something that stays with you, right? So the public key is freely distributed while the private key is kept secret. Another key important here thing is secret. Only you should know your private key. Never share, never send, never distribute your private key. Quite important. We studied as well when we were learning the history of cryptography. Asymmetric encryption is also known as public key cryptography. Whenever somebody says public key cryptography, you need to understand we are talking about the asymmetric encryption, right? It allows secure communication without the need for a shared secret key, right? This is what points to symmetric, which we are not doing right now, right? So what it says is it allows secure communication. If you see hello Alice message is being sent to from Bob to Alice, it is sent in an encrypted manner and then getting decrypted, but the key is not being shared. If you see, this key is different from this key. The key that has been used to encrypt the message is different from the key that has been used to decrypt the message. And that is what is the key takeaway, guys, that it allows secure communication, but you don't use a shared key. Shared key is always used in symmetric encryption. So asymmetric encryption is based on mathematical problems that are difficult to solve, and such as discrete logarithmic problems and factorization of large numbers. And we will study about this. Don't worry if it sounds confusing. So what it says is, and as we already studied, any encryption, decryption that we are doing is always based on a mathematical algorithm. Or you can also say it's basically something like a mathematical formula. It's not only a formula, but a collection of formulas. And on top of it, when we talk about keys, we always say, and most of the time we are talking about large prime numbers that we are talking about when we are applying these keys, or when we are creating these public-private key pairs, right? So in the very early videos, we studied the CIA triad, right? You might remember the CIA triad. So the asymmetric encryption helps us to address the confidentiality, integrity, authentication piece of it. And on top of it, you can get non-repudiation. What is non-repudiation? It is a situation where an author cannot dispute the validity of a contract, and it's done through a concept of digital signatures. Again, we will see in the forthcoming videos. But all I want to say is it's so important, and there are so many advantages of asymmetric encryption. Like, it can easily answer all problems which are given by CIA triad, which are confidentiality, integrity, authentication. But now the thing is, if a certain thing has got advantages in life, there might be some caveats or some disadvantages. Now, if you can remember, we said that symmetric encryption was very fast. It uses less computation power. Now, that becomes the disadvantage for asymmetric encryption, because asymmetric encryption is considered to be slower. Why it is slower? Because you need to work. So there's a lot of CPU computational power needed, because you need to work on a lot of mathematical operations, right? That's why it is considered to be slower. And you're not using the same key that has been used to encrypt and to decrypt. So it's always based on complex mathematical operations. And if you talk about use cases, asymmetric encryption has been used in various applications where you need to send secure messages like SSL, secure socket layer, TLS, transport layer security, PGP is the pretty good privacy, we call it. Then SMIME, which is an extension to the simple mail transfer protocol, or the SMTP. So all I want to say is there are a lot of, say, use cases for asymmetric encryption as well. But as we studied in symmetric encryption, they were prone to some brute force attacks. Similar way, the asymmetric encryption are also a bit vulnerable to the brute force attacks. You can also have some side channel attacks and some quantum attacks. So quantum is a pretty new concept, I would say, where quantum computing is coming, which is using the computational power of the computers to break these encryption algorithms, or to break these encrypted messages, right? And as we studied in symmetric encryption, because symmetric encryption has certain advantages and disadvantages, it means that it needs to be used in combination with different other algorithms. So that's why in normal computational or normal, say, when we are sharing messages on the internet, we always used a combination of symmetric plus asymmetric. So symmetric plus asymmetric is always used. That's why we always need to study symmetric encryption, what it is, what are advantages and disadvantages. Same way we need to understand asymmetric. But if we combine these two, then we get a powerful solution, which is kind of a hybrid encryption, which we use in our day-to-day, I would say, secure communication. So this is all about asymmetric encryption. In the next video, we'll take a look at kind of an example where Joy needs to speak to Aileen and needs to send the hello message, how it works. Thanks for watching. So let's try and understand the asymmetric encryption using a very simple example, again, between Joy and Aileen. Now, when we studied symmetric encryption, there also Joy and Aileen were talking to each other and they were using the same key, right? What happens here is, if you see, Joy is having his own public key and secret key. So think of it as a private key, right? So wherever I'm talking about private, I'm actually saying secret key, right? So here Joy is having his own public key and private key, and Aileen is having her own public key and secret key. So as we studied, whenever we talk about asymmetric encryption, there will always be key pairs. But remember, these key pairs, now we are saying two people need to talk to each other. Both these people have their own set of public key, private key, public key, private key at the other end. If you see, and that's why I've used a different color coding. So here I have a different color and here I have a different color, which shows that they are different, right? They're not same, they're different keys. Okay, now let's start and try and understand. So Aileen this time tries to send a message hello to Joy, right? Now we know that Aileen shouldn't be sending the message as original text. What she would do? She would use Joy's public key and encrypt this message, right? Now you might ask, how does Aileen have Joy's public key? Yes, why not? Because Joy has distributed it freely to the entire world. So Aileen picks Joy's public key, encrypts the message, and what do you get? You get a ciphertext, right? So now we say that this is my ciphertext. Now by now we have studied that if you are taking original text, you are applying an encryption key or encryption algorithm, you get a ciphertext. What happens at the other end? Now what happens at the other end is Joy receives this message, right? Now I told you guys that if you are encrypting a message using a public key, then there is only one and only one key in the whole world that can decrypt this message, which is, any guesses? Yes, it is Joy's private key. So if now Joy applies this secret key, this one, onto the message, what will Joy get? You get hello, right? That is what all it shows, that you are encrypting using Joy's public key, but then when you have to decrypt, you have to decrypt using Joy's private key. And what does it give? It gives confidentiality. You now might remember the CIA triad we studied. So confidentiality, what it means is that the information that is being sent is confidential, which means if you are talking about privacy, because only Joy can actually decrypt this message, because nobody else in the world, any hacker in the world won't be having Joy's secret key or the private key. That is why we say if I'm exchanging confidential information, this is the mechanism I would be using. And this use case is a perfect use case for confidentiality or maintaining privacy. Why? Again, I'm telling you, because it was encrypted using Joy's public key, it has to be decrypted by Joy's private key. And the only person in the entire world who would be having Joy's secret key or Joy's private key is Joy himself. So thanks for watching, guys. Okay, so after having a look into asymmetric encryption and addressing confidentiality or ensuring that the information that was sent as a confidential message, it's time to take a look into the second form, which gives you integrity and authenticity. So let's take a look. So now your friendly folks, Joy and Aileen, are back. So Joy has his own public key, private key. As I told you, that secret key is nothing but the private key, right? And Aileen has her own public key and private key, right? So let's see how both can share the information. Let's say Joy has to send a message hello to Aileen. Now we all know by now that any message that you have to send, you have to encrypt, right? Now this time I'm actually encrypting using my secret key, right? There's a difference. In the previous example we studied, we were actually using the public key to encrypt the message. Now this time we are actually using a private key to encrypt the message, and you'll see that it actually helps address a lot of different use cases. Now let's say you take the message hello, you use Joy's secret key to encrypt the message. What do you get? Yes, you get a ciphertext. So this is the ciphertext I got, and this ciphertext, when it arrives to Aileen, Aileen knows that because it was encrypted using Joy's private key, the only key in the world that can decrypt this message is Joy's own public key. Very good. So because this message was encrypted using Joy's private key, it has to be decrypted using Joy's public key, and this public key would be available all across the world because it is public. I've distributed it across to the whole world. So then after applying this public key, Aileen is able to get the message hello. And what it gives you? It gives you authenticity and integrity in one go. Now you might ask, what is authenticity? So authenticity means that the information is authentic, or it's actually coming from a trusted source, right? So which means that Joy himself is a trusted source. Now, if you think in that sense, that because anybody in the world could decrypt that message using Joy's public key, it doesn't matter that that you are using Joy's public key and you have access to the public key, that is fine because you would have access. But it actually shows that the message or the source is actually a trusted source, right? And the other thing that it indicates is integrity. What it means is that the message that has been sent has actually not been tampered. So nobody has tampered, or I would say changed the message. So I would say not tampered and not changed, right? Or modified in any sense. So that's how you are ensuring that through asymmetric encryption, you are able to get authenticity, that Joy is a trusted source, and the information that you're getting from a trusted source is not getting changed in a way that is not getting tampered or changed, and This is how we are able to address the confidentiality, the integrity part of the CIA triad that we have studied. So as I said, in the last video, we studied how we get confidentiality. In this video, you can see that if Joy has to send a message to Aileen, Joy is encrypting using Joy's private key, which is close to his heart, which is secret to him. But the only person in the world or the only key in the world that can decrypt that message would be Joy's own public key. So that is what we used, and we get the message, hello. So thanks for watching. Hello and welcome to the demo on asymmetric encryption using OpenSSL. So guys, what we will do in this demo is that we will first work on creation of a public private key pair. So we'll create a public private key pair for Joy. We'll create a public private key pair for Aileen. Then we will exchange the public keys. Because they are public keys, you can exchange Joy's public key with Aileen and Aileen's public key with Joy. Then what Joy will do is Joy will encrypt the message using Aileen's public key. Now the question is, which is the only key in this world which can decrypt this message? The answer is right. So the only key in the whole world which can decrypt this message would be Aileen's private key, because Joy encrypted the message using Aileen's public key. That's why Aileen has to decrypt the message using her private key, right? So this is what we will take a look in this demo. So first what we need to do is, I would suggest that you actually create two directories, let's say called Joy and called Aileen, just to show that who is your sender, who's your receiver. You can give any names, but this is what I have chosen, right? And then what we need to do is we need to create a private key for Joy, right? So simple command, I'll just say OpenSSL generate RSA minus AES256 is the algorithm that I'm giving, and minus out is minus output. I want the private key to be called joy_private.pem, and what is the key length? It is 2048. Now whenever you create your private key, it has to be protected. Because this is a PEM file has to be password protected. So the password I give here is PA55WORD, PA55WORD, right? So this will create my, Joy's private key. So let me copy it to, actually let me move it to Joy_private to Joy, right? And I will go into the Joy folder. So right now I'm in Joy folder and I've created Joy's private key. The second thing is that we need to now get the public key for Joy. So because we have already created a private key, we need a public key as well, so that we can exchange with Aileen. So we do OpenSSL RSA minus in, which is minus input. I'm giving the input as private key, and I'm saying pub out. I want the public key to be out in the form of joy_public.pem, right? It again asks me the passphrase. Because I protected my private key using a password, I need to give that password. So it says writing RSA key. So now what has happened is Joy has got a key pair in terms of Joy private, Joy public. Now we need to do the same with Aileen, right? So let's go to Aileen and do the same thing quickly. So we create a private key for Aileen. Again, we give a password. You can give any other password, but for simplicity, I'm just giving the same password, right? And then we create Aileen's public key. So we create Aileen's public key, we copy this. So I would suggest that when you guys are doing it, just simply copy paste and you should be able to work on it, because this is a working example. Okay, so now Aileen and Joy have got their public private key pairs. And now the next thing is we need to exchange the public keys with each other. So what it means is that Aileen needs to send her public key to Joy, okay, and Joy needs to send his public key to Aileen. because these are public keys, so you can exchange or share with the other person, right? So Joy now sends his public key with Aileen. Perfect. So we have exchanged the keys. Now what we need to do is Joy needs to encrypt the message using Aileen's public key. So for that, let's first create a file. So let's quickly create a file. We call it hello.txt. In that we say this is a top secret message. Okay. And we save it. So now Joy has created a top secret message and he wants to encrypt it. Now when Joy is sending, Joy is encrypting using Aileen's public key. So let's encrypt this message using Aileen's public key. And the command that we are using is rsa-util. So we say openSSL rsa-util minus encrypt minus in key, because I'm using Aileen's public key, so I'll give in key, minus pubin, and in input I'll give the hello.txt, which is my file, and in output the output file that I need. Okay, and if I see now, my encrypted file has been created. So yeah, as you can see, this is a garbled encrypted file. Now I need to send the encrypted file to Aileen. So because it's encrypted, I can send it over. There's no problem sending it over the network. So I send this encrypted file over to Aileen. Right. Let's say now we go to Aileen. Now Aileen receives this encrypted file, and as I said, we encrypted using Aileen's public key, right? So the only key in the whole world which can decrypt this is Aileen's private key, because it is Aileen's private key. It is close to her heart. It is with her. Nobody else has access to it. So she can actually decrypt this message using Aileen's private key. Okay. So if I copy this and I say, now I'm saying OpenSSL rsa-util minus decrypt. Previously I was saying minus encrypt. I'm doing a decrypt. In minus in key, I'll give Aileen's private key. So Aileen_private.pem minus in is encrypted file.txt, because this is the input file I'm giving. And I want that file, the output file, to be called topsecret.txt. Now it asks for the Aileen's passphrase. If you have kept a different passphrase, then you need to give that, but I've kept the same, so I give that. And then I cat this, and voila, this is the top secret message. So the actual file or the message has been decrypted fine. So this was a perfect example of asymmetric encryption, where both the sender and the receiver, Joy and Aileen, came up with their public private key pair, and we used one key to encrypt and the other key to decrypt the message. So thanks for watching. Okay, so after taking a look into symmetric encryption and asymmetric encryption, it's time to look into hybrid encryption. Now, as the name suggests, hybrid means which is basically a combination. So you are using asymmetric plus symmetric. Now, we know by now that there are several advantages and disadvantages of each encryption method. So with symmetric encryption, we've seen that it uses the same key, and what it gives you is a faster communication, and also it uses less computational power. With asymmetric encryption, the good thing is because you have multiple keys, you don't use different keys, right? But it does have its own caveats, because it's considered to be a bit slower, and it can actually lead to more computational power, right? So that's why if you see, there is a need for a hybrid encryption. But guys, I would suggest, if you feel confused, because it can get slightly complex in terms of hybrid encryption, so you can always try and watch this video multiple times. I'll try to go slow to give you a good understanding of this. Okay, just remember, the aim of this whole exercise is using asymmetric encryption and then trying to come up with a symmetric key, right? So we need to somehow come up with a symmetric key so that both the parties, say Joy and Aileen, have the same symmetric key without the need to actually transfer the symmetric key across. And then we'll see the magic, how it actually works. Okay, so let's say, so Joy and Aileen are here and they want to talk to each other. So Joy has his own set of public key and secret key, and Aileen has her own public key and secret key. Now, what we do is basically, first of all, so Joy will come up with a new secret key, right? So you had this public-private key pair, and you come up with a randomly generated new secret key, right? Now, what we do is we take this secret key and we combine Aileen's public key. So if you see here, I'm using Aileen's public key, which is fine because Aileen's public key is available or distributed all across the world. So Joy can use this secret key and combine to get a new secret key, right? Or a new key, right? Now, because this is a new key, I can easily send it across, and it is already an encrypted key. So also remember that this is an encrypted key, so it can be actually sent across the wire, right? So I send across this encrypted key over the wire to Aileen. Even if somebody interprets or intercepts this in between, it won't be a problem because it's already encrypted, right? Now what happens, because this key, when this key was how this key got generated was using Aileen's public key. So any guesses? Yes. So there is only one and only one key, which is Aileen's secret key, which can decrypt this to get the key back. So if you see, what I do here is I combine this secret key with Aileen's secret key, right? So I'm combining this or decrypting this to get a new key. And if you see, now what has happened is we've got the same key on both sides, right? So up to here, I believe it is clear. I'll quickly go ahead and describe it again. So Joy had his own public-private key pairs. Aileen had own public-private key pair. Joy came up with a new secret key and then encrypted that secret key with Aileen's public key to get a new encrypted key. Now this key was sent across the wire to Aileen. Now Aileen could decrypt this key because it was encrypted using Aileen's public key. So the only key in the world that can decrypt is Aileen's secret key. Now when you did that, you automatically get the same key. So if you see, the key that is here is same as here. So what it gives you? It actually gives you symmetric key, right? Because now both the parties, Joy and Aileen, have got their own secret keys and they are same secret keys, right? And that's the benefit. So if now Aileen uses this mechanism and let's say encrypts this message using this key, then it goes back to hello, right? So what is happening? So Joy had to send this message hello. So Aileen can actually use this, encrypt this message, and Joy can easily decrypt because Joy has already got this message with him, right? So once again, Joy sent a hello message. Aileen is sending the hello message, let's say back. Now hello, when it is sent, it is being encrypted using the secret key, and the same secret key is being used to decrypt it, right? To decrypt it. So here you are decrypting it. Okay, so Joy is decrypting it and reading the message hello, right? Now what it gives you? So it basically gives you the base for SSL or TLS. So we call it secure socket layer or transport layer security. So all this mechanism of hybrid encryption actually gives us what we call SSL TLS. We will study in more detail how a TLS handshake takes place or how a client and web server talk to each other on a secure channel. But the basics around that is hybrid encryption. That's why it was very important to delve deeper and get a good understanding of hybrid encryption, where we are using a combination of asymmetric and symmetric key. As you see here, we came up with a new key. We encrypted using Aileen's public key, sent it over to the wire, decrypted it, and we got a secret key. Now this secret key is actually used for all the encryption and decryption. Here, when you're sending a hello message, you encrypt using this, and then you use the same key to decrypt and get the hello message back, right? So that's all I wanted to describe you in terms of hybrid encryption. Thanks for watching.